All right. It's a beautiful Saturday morning once again, and I would like to welcome everybody to today's webinar titled Right Start Programming with R Language. Right Start Programming with R Language is organized by Abuja R Users Group. Abuja R Users Group comprises of R professionals and R learners who are passionate about using this programming language in the field of data science, data analysis and analytics, and data engineering. Without wasting much of our time, myself, Obani Fidelis Ademola, and Abubakar Ibrahim will be co-hosting today's event. The agenda for today is, I think we can all see it on our screen. So as we're starting now, we are welcoming the participants. So if you are joining us for the very first time, I would say this is one of the best decisions you would make, as this is going to help a lot, especially if you're trying to delve into the world of data, or you're already in the profession and maybe you've been using other tools like maybe Excel, and you want to upskill yourself. I think this is a very good platform for you, and you're going to learn a lot. So now we'll be introducing the organizers of this event. So the co-organizers of this event are Obani Fidelis Ademola, that's myself, Abubakar Ibrahim, the co-host, Adamu Danladi, Balogun Stephen, and Adenito Bilikisu. Also, today, we have our guest speakers who are ready to take us through the voyage of learning. We have our first speaker, who is Bilikisu Umi Adenito. Bilikisu Umi Adenito is a business data analyst and R Studio certified instructor. So she's a co-organizer of today's event. Then we have also Stephen Balogun. Stephen Balogun is a data scientist and public health physician. So they are both R professionals who are ever ready to take us through this journey. So without wasting much of our time, we would like to start the training sessions as we also await other participants to join us. Bilikisu Umi Adenito, the floor is yours now. Thank you.
Okay, good morning, everybody.
Good morning.
Okay, I think, Stephen, how you?
Good morning, I can hear you.
Okay, I think you'll take the lead. I want you to take the lead. So you share your screen.
That's fine. Good morning, everyone. Good morning to our participants. We're happy to have you here today. I'm going to start the presentation, so I'm going to just go ahead and share my screen. Thank you. And just give me a minute to also put on my video. Okay. So yes, good morning once again, everyone. And welcome to the Right Start Programming with R Language. Again, thanks to the host for the initial introduction. So this is just a little bit more about myself. As rightly introduced, I'm a public health physician and a data scientist. I currently work in the field of epidemiology and public health. I am author of one of the R packages, the Tidy NDR, and I'm one of the co-founders of R for HDS, that's R for Healthcare Data Science. And below are some of my details. You can see my personal website. You can follow me on Twitter, and then you can see my LinkedIn profile for more. So I will let what the co-facilitator for today's session introduce herself, and then we're going to go ahead with the first part of this presentation today. Over to you, Bilikisu.
Okay, thank you. Hello, everybody. I'm Bilikisu Mumi Adenrito. So this is my Twitter handle, and I also have my personal website on Bilikisu, badenrito.github.io, as you can see on the screen. So I'm also available on LinkedIn, so you can search for my name there, and I'll be free to connect with you always. So I'm also the principal consultant, also a freelancer with my personal outfit, that's Business Data Laboratory here in Abuja. I'm the founder and co-organizer of Abuja R User Group, and the R Leads is Abuja. Thank you.
So would you also like to tell us a little bit more about the Abuja R User Group?
Okay, yeah, great. It's been a long journey, but a really short, but it's been wonderful meeting a lot of people. We actually started Abuja R User Group October 19, 2019. Yeah, 2019. Yeah, I get it. So that was the first meetup we'll have here in Abuja. It was really wonderful. We had a lot of people coming in to really witness the opening. So ever since, we've been able to really host wonderful R users from across the professional field, education, and the academics in general. So that's the little we have about our user group, and we've been able to influence so many people and also mentor a lot of people, and we're glad we are in existence here in Abuja. So thank you so much.
Okay, so we'll go ahead to the first part of today's session. And so basically, this is what the course will teach our participants today. But before I go ahead with this, I need to apologize that I am currently experiencing some fluctuations in my network. I hope it's really going to hold, and we're going to have a wonderful session today. But please let me know if I lose our participant at any point during the presentation. So again, we have divided this workshop today into 3 parts. The first part, which is the getting started, basically will walk us through why we need to use a little bit of overview of what data science is all about, and the tabular data that we'll most often be working with in R. And as we have previously communicated on the platform, how do you go about installing your softwares and setting up your workspace and the rest of them? So part 2 will be taken by Bilikisu, and it's going to walk us through the main meat of today's workshop, which is how to get your data into R, how to do your analysis, and how to do the visualizations you'll be interested in learning. So part 3 will talk about, okay, you've done your visualization, you've got your results, you are really absolutely excited about what you see. You really want to share those results with others. So how do you communicate your results? Do you need to start copying and pasting your charts? Do you need to start copying and pasting your figures? Or there are automated ways to do these things? And then we'll see a bit about that. And then we'll talk about what are the next steps? Where do you go from here now that you have gotten the right start to R programming, like this course is intends to really teach. So who is the class for? We are making a few assumptions. We're assuming that our participants today are new R users, or people who are just interested in going back to the basics and starting from the scratch, practically have no prior programming knowledge. So if you feel like, oh, I'm not a programmer, I don't even know what that means, please, this platform is for you. Today's workshop is for you. And you really don't have to know anything about statistics. You can just be as green as you are, and you will be able to follow this class and get the basics for working with R. So on this note, we would just like to tell us a little bit about what R can do for us. Right, you probably are aware that R is a statistical programming language. You can use it to do your analysis, especially quantitative. But it's also good to know that R can be used to do qualitative analysis. If you have those focus group discussion, key informant interview, and any of those text data that you would like to analyze, you'll be surprised about the power of R to be able to do these things. You can generate your word cloud and a lot of other text analysis in R. Recently, R has also gone into being utilized for specific reasons like analyzing musical tones and a few things like that. There are a whole lot of things you can see online. This particular slide presentation is also designed using R. So you can also use R to make wonderful slide presentations that are quite interactive and a lot of other things like that. So when it comes to the power of visualizations, we have great graphs that you can make with R. You can do your maps. A lot of people these days are interested in doing geographic maps. They want to be able to use data and plot it to locations and the rest of them like that to be able to inform decisions. R is excellent in this area, and you'll be amazed about how R supports the development and map visualization. And recently, people have also taken R into other things like games. So you can use R to design games. I'm going to show us an example in a bit. It looks really real and it's super interesting. And you just wonder, how was this person able to use R to design games? So, yeah, that's possible. You can also use R to plot arts and to design arts. And it looks so real. You would think that they were photographs. And Ijamaka Ayeni is one of the specialists in this area. I'm going to show us one of the arts she has designed using R, and you'll be super amazed. Today, I'm super amazed that how do you do this with codes? It does really just look like a picture that was taken and things like that. R is also good for developing websites. So if you want to develop your own personal website, so you want to be able to blog and share some of those things, or you even want to design maybe you're a teacher or you love to teach and you want to be able to design a learning platform where people can interact, learn, take exercises, quizzes, and the rest of them. You'll be surprised that R can do a lot of those things for you. So basically, not that R is a jack of all trades, no, but we're saying that there's a lot R probably can do for you. It depends on exactly how you want to use it. So, and it's great, right? You don't have to start jumping from, oh, if I want to do quantitative analysis, I probably use this software. If I want to do this, I want to use that. If I want to do visualizations, this is the software, or have to learn different programming languages. You practically can just focus on learning your R and being able to do all the things you want to do. So we've included a few examples of those things that R has been used for. So on the right here, we can see some dashboards that have been created using R, and you want to agree with me that this really looks beautiful. I'm not really sure if you want to do, if you have really seen any dashboard more beautiful than this. They look really great, right? And then these are the other ones I've talked about. On the top left is the gaming platform, FIFA 19. I was designed using R. And basically, you just search for this on Google, you should be able to see it. And on the bottom left is the art, looking like a lunar eclipse that Ijamaka Ayeni designed using R. And you want to agree with me that this is just great. How do you design? This is not a hand drawn, this is not a drawing, this is not a picture, but this is just a couple of codes that have been used to create something as beautiful and as gorgeous as this. And on the right are platforms, websites, blogging platforms that have been created using R, and really does look wonderful. So basically, to let you know that, again, R is powerful and can help you do a lot of things. So if you have chosen to do R and join us on this workshop today, I can tell you categorically that you've made a very good decision. So beyond all those things that R can do for you that we have seen, it's also good to know that R is open source. You don't need to You can easily see all the codes, and a lot of people contribute to this. R is absolutely free. You can use all the powers of R like we've discussed in the last few minutes without having to pay any amount of money. So you can download all of them online and you're good to go. Isn't that wonderful? R has a strong community support. Abuja R user group is one of them, supporting the community in Abuja and in Nigeria and in the world globally as a whole. And there are a whole lot of other community supports that are available for you online, physically, and our users are almost always willing to lend a hand when you need it. So you can almost be certain that if you reach out to somebody who with a particular challenge or something like that related to R, the person is most likely or definitely really going to try and provide you with the support that you need. We've seen how broad R is. Practically said R can do quantitative, qualitative analysis, most of those things you'll be interested in. And it gives you reproducible codes, isn't that right? I recall a couple of days ago, giving somebody a task to do and submitted the assignment, and I was like, where's your code? The whole purpose of using R for something like this is to be able to see your codes, see the steps you have taken, and also just double check that everything, the results that you are presenting is as a result of the codes that the codes that you have written, right? Now, if you want to say, oh, okay, this is wonderful, but where can R get me into? You'll be amazed at the number of industries that are using R, and this number is increasing rapidly. Has increased rapidly in the last couple of months to years. I've mentioned a few examples here of most of the social media platforms to also use R in the background. And also, with the advent of COVID-19, a lot of health and public health organizations have also delved into the world of R, and they're rapidly scaling it up. So we can see a few of them on this platform. A few weeks ago, there was an advert from really related to R for public health, and I was just like, this is excellent. So just to let you know that, again, there are a whole lot of industry. So you would not, irrespective of the sector where you are, can be rest assured that there are companies, there are industries within your sector that are already using R. Right. So having told us a lot or a little bit about what R can do, it's also good to just, like we said from the beginning, we are not making assumptions. So we're just going to do a quick overview of data science, or a little bit of what you should know as a background before we start the coding experience, just to get all of us on the same page. So basically, you are interested in data science. Yes, even though you might not be a programmer, you need to learn a little bit of programming, because R itself is a programming language, so you have to be able to code. But don't worry, this you'll be able to pick. The language, the R language itself is very easy to learn. You will definitely need to know to be able to reason scientifically, because it's all about making inferences from what you are seeing, being able to follow logical conclusions, right? And then understanding data, knowing that, okay, this is how my data looks like, this is what I can get as a result of the data that I have, and things like that. But like I said again, don't worry, these things are relatively easy to pick up as long as you're committed and you show the interest. So there are several fields in data science. We will not delve into that. So a mixture of all these combinations, a right balance will get you exactly what you want to do. So if you want to specialize in just visualization, for example, you just want to be plotting those charts, those maps, and the rest of them, please feel free. It's going to get these things done for you, right? With the right combination. Okay, so now when you want to do your analysis, you already have collected your data, maybe in any spreadsheet, maybe Excel, CSV, or any other format, or maybe it's even online on the database. Then you really want to get your results. Basically, we are sharing with us this workflow as proposed by Adley Wickham, one of the gurus of the R industry. And that's basically what you see on the right. It talks about, okay, you have to be able to get your data into R, that's importing your data. Data sometimes we need to be cleaned up, tidied, because a few formatting might not be completely accurate. So you might just need to do some tidying of the data, and then you might just do some manipulations, not like making up figures, no, but transforming your data from one format to the other. And before you go ahead and run your analysis, do your visualizations, and when you have your results, then you're able to just communicate them. And we're going to walk you through most of this, practically all of these processes during this workshop period. So sit down, enjoy the ride, and we are promising you that it's really going to be a good show today, and you're going to enjoy every minute of your time. All right, so we've talked about the data science workflow. We just want to also mention that most of the data that you're going to be working with are going to be tabular data. We're just saying they're going to be spreadsheets. You're going to have rows. Rows are horizontal lines. So you have row 1, row 2, row 3 to the last end of your data. And then you're going to have columns. Okay, so columns generally contain the variables of interest. So you might have columns, for example, that collects data related to age, related to weight, related to country of origin and things like that. So they're going to be in your columns, all right? So again, rows are horizontal, columns are vertical. And then there is a concept that we call the concept of tidy data. And for many people who are probably used to Excel, collecting data using Excel and other platforms, and this really becomes very important because most of us know in the world of data science or data analytics, most of the data out there are really not tidy. And you have to understand that concept of tidy data to be able to put it in the right format that makes analysis a lot easier. So what is tidy data? Basically, as proposed by Adley, I believe, basically just composed of 3 components. That a row should only have an observation, okay? 1 row, 1 observation. So if you are collecting data about me, for example, all of my data should fit into a row. If you are collecting data about Bilikisu, all of Bilikisu's data should fit into a row. As much as possible, try not to split the data from one person into multiple rows, all right? That's one of the first criteria. The second criteria is that every variable should only have 1 column, all right? So if you're collecting data about age, let everything related to age be in 1 column. And don't spread age into too many columns, right? It's not that, well, but of course, this is quite common in the data world, but we're saying such data is not tidy. If you want to make it tidy, make sure that 1 variable, 1 column, right? And then the third one automatically flows by the time you have satisfied the first 2 criteria. So this quote from Adley Weekend that I really love says that tidy data sets are alike. When you say tidy data, you practically can tell yourself, well, this is tidy data because they have just fulfilled this criteria. But messy data are just messy in their own way. It's you can't fathom the number of the variations in untidy data or messy data that you can see. There are a whole lot of messy data out there. And sometimes the data scientists spend even more hours trying to tidy up the data before the analysis and the actual analysis itself. But it's suffice to know that as much as possible, just have this behind the back of your mind that there's a concept called tidy data. So just to put things in perspective, I've thrown these two tables here. So we can just see in a bit. What we have, the one we have on the right has four variables, 4 columns, right? And we can see that country is in the first column, year is in the second column, case and population. And if you look at it very carefully, you will agree with me that this basically, they meet the criteria for tidy data. But if you look at what we have on the left, you have country year rates. And you ask yourself, rate, what makes up a rate? Right, in this case, in this scenario, rate is cases over population. That's how they got the rate. Meaning that rate is actually composed of 2 different variables, which does not meet the first criteria or one of the criteria that we talked about, that a variable should have its own column. Rate has 2 variables in it, case and population. This is an example. So this just lets us know that, okay, like I said prior, there are several ways with which messy data can present or untidy data can present itself. And this is just one of those examples, okay? All right, now we've talked about tabular data. How are these tabular data formed? Okay, how are they built up? And that's the concept of atomic vectors in R. So atomic vectors are just the building block for data generally, and especially for tabular data. And I will be referring to this particular table that we have here a bit. So basically, we have 4 common atomic vectors in R. The first one is called double. Doubles are generally continuous variables. So when you have any variable that can assume a decimal point, that's a continuous variable. R interprets this as a double. When you have discrete variables that can only assume whole numbers, you can't have fractions or decimals, but these are integers, and R interprets them as integers. And then when you have strings, text, characters, okay? But I love this definition that I think I got somewhere regarding characters. Is any value, any figure, any write-up that is surrounded by quotes, irrespective of whether it is a number or text or anything like that. The moment you have it quoted, basically R interprets them as characters. And I think most of the other languages also interpret them in this same manner. And then the fourth common one that you will see frequently is the one we call the logical variable, the true or false. Okay, in R, they are always written in capital letters true, capital letters false, or sometimes as just T and F. All right, so these are the common building blocks that you see. I'll just quickly go back to this table to just walk us through the table on the right. We can see that country contains characters because they are texts, and these are just characters. We can tell ourselves that year actually contains integers because you cannot have a 1999.5 year. Years will always be whole numbers, right? So year is integer. About the same thing with cases because you have to count cases and then you have to count population. So for this particular table, we have country, which is the character, year, cases, and population, which are all integers. But take for an example that you now decided to calculate rates, and you now say cases divided by population, you will agree with me that that's going to give you decimal points, right? So rate becomes a double. So this is just showing us a few examples that you can see. And one other thing we should quickly know that at tabular data, usually you can only have one particular type of variable in a column. So if you're going to have integer in a column, then every other entry into that column should be integers, or they will be forced to assume integers. If you have characters in a column, then every other entry into that column will be forced to assume characters. But that does not mean that you cannot convert variable from one form to the other. We will not go into details about this, but you will agree with me, for example, that you can round up and assume 0 decimal place, whole numbers for figures, and then you might have just been converting your continuous variable or your double to integers if you are forcing them to all assume whole numbers. There are other types of vectors or variables in R, but we will not be talking about these ones today, but just to let us know that these other types are generally derived from these 4 basic ones that we've talked about. They are derived from either double, integer, or something, or one of such. All right. So that's just a bit of introduction into data science and maybe a bit of statistics that we think is relevant for the session today. I hope you did enjoy, and if you have questions, clarifications, we're going to have time to take for Q&A at the end of this session. So please feel free and let's discuss those clarifications that you might have. So coming back to the session today, we are hoping that you have been able to install the R software because that's what we'll be using for the session today. If you have not, please, in the next few minutes, we're going to just walk ourselves through the process of installation once again. You have also installed R Studio. I'm using R Studio and R for this particular session that I'm taking. And you have also installed some R packages. I know that Bilikisu shared some packages yesterday for us to install. Bilikisu, if you could just go ahead and please drop or maybe one of the hosts can please help us drop the link to our software installation, R Studio, and the R packages that we have shared for those of our participants who might really not have had time to do this. Maybe they can just do that and catch up with us. The optional tools, the R tools for Windows, it's quite optional. We won't be talking about that, but I encourage you, if you're on Windows platform, you should also consider installing R tools. And then the other one for the Mac OS. Of course, you need internet connection for all of this. And for today's session, definitely you have internet connection on your device. That's why you're able to connect with us today. So please go ahead and follow the instructions if you have not done any of this installation. So again, for installing R, you just go to this website and then it will take you to this screenshot that you're seeing on the right, and you can choose your device for Linux, for Mac OS, and for Windows, and you can go ahead and do your installation. I see that Bilikisu has also dropped a short YouTube video to guide our participants if they need regarding the installation processes. Please feel free to catch up watching the videos, maybe sometimes later, and follow the guidance in the video. All right, so this is for installing R. It's easy. Basically, I just encourage people just accept most of the default settings and you'll be good. For R Studio, you just go to the R Studio website, rstudio.com, and you are most likely going to be directed to this particular page. There are professional versions, but I assure you, for most of what you'll be doing, the free version of R Studio is good enough. I have practically been using the free version of R Studio, and it's really been a great experience for me. So this is basically where you go to install R Studio, and I believe the process is, again, it's basically just accepting defaults, and in no time you should be set. So for those of us, this software is installed on our devices already, generally we want to encourage to do a minor modification to the default settings. So I'm just going to go ahead and show us right now, even though we also have it displayed on the screen right now. So if you come up here, you can see the tools. I need to also quickly say that I've changed my own default theme a bit. The default when you install R on your platform is going to be white, and this version of blue, like you can see on the screen. But I have changed my theme a bit, but no worries. Apart from just changing the color setting, every other thing is like default. All right, so if we go to the tools, which is just at the second to the last tab at the top here, and then you click it and we go to the global options, which is the last on the list of the drop down. It's going to open up a window for you, and it's that window that you just need to do some minor modifications. So we generally encourage that you deactivate or uncheck your workspace. These three places that I have has been highlighted on the screen. Just make sure that you change the safety workspace to never, and then deactivate uncheck the other two places. Basically, it helps to improve your programming experience. It helps to improve the reproducibility of your code, your coding, and it helps to ensure that when you close your environment, when you close your workspace and you come back to it, you don't experience undue headache and hassles. And when you also share your product to people, they also don't experience undue headache and hassles that sometimes people face. So this is just our own recommendation. It's not like I say, feel free to adopt whatever platform really works for you. All right, so that's setting up your workspace. The other thing we want to naturally encourage people to do is that R can help you to compartmentalize the work you're working with. So if you're working on multiple projects, multiple data science activities at the same time, you can separate them into different folders and be able to track exactly how you work or the progress you have made in each of these folders. So we encourage that you just use one project for each single set of analysis that you are doing. And this is also relatively are easy to do. So we'll just go ahead and show us exactly how that works again. So what we'll do is that we'll go to the File tab. The File tab is the first option in your RStudio. So maybe I should just give our participants a few seconds to open up their RStudio if they have not done that already. Please feel free to catch up and just let me know if I'm losing you. Just drop it in the chat box, and I'll just take my time to go over it in a bit. All right, so to start the a new project, like I said previously, click on the File tab. The File tab is the first option, the top row of your RStudio environment. And then if you click on File, the second option there on the list item is the New Project. And then you click on New Project, it's going to open up a window for you, similar to what we have displayed on the screen. And then it's going to ask you, do you want to start the project in a new directory, meaning a new folder? So if you select that, it's going to create a new folder for you, and it's going to also make sure that your project is set up there. But if you already have a folder that you've started using, and then you just want to make that folder your project folder, go ahead and select the version existing directory. Most often you select either of the first two. And if you click any of them, I just go ahead and click the first one. It's going to ask you, what kind of project are you working on? Are you developing a package or any of these? If you are not developing a package or any of these other specialized things, please just click on the first option, New Project, and then just tell her exactly what do you want to name your folder. If you are using a new folder, what's going to be your folder name, and where is your folder going to be located? And then go ahead and click on Create Project, and then you'll be fine. All right. Well, I'm not creating a project right now, so I'm not going to go ahead and create that. All right. So I see a few questions in the chat box already. Somebody is asking that, are we going to be sharing this? Yes, I believe we're going to be sharing the materials after the session. So please feel free. We want you to be able to catch up. You're going to get access to the recorded video. That's why this is being recorded. And you're also going to get access to all the materials we're using. All right. So Aurora is asking that, when do we create a new project and when do we create a new R script? All right. Excellent question. All right. Generally, my thought is that to create a new project, the moment you realize that you are working, you are starting something new. You are doing a new set of analysis. So start with creating a project, right? That's where you start from. And we're going to see how we're going to create, when you create scripting a bit, right? So when you create project, for example, I might be working on 5 different sets of analysis, maybe 3 at my workplace, 1 for Abuja R user group, and another one for another platform. I can create 5 different projects for each of these ones. For example, this particular workshop today has its own project directory. And that's why it becomes easy for me to share that project folder with anyone who is interested, because it is completely designed for this workshop today. That's a project for me. If I have another session, I'm going to start another project, and I can easily share that with somebody else. There are a whole lot of advantages working with projects that we will not be able to cover today because of our time. But just to let us know that we recommend that for each work you do, create a project. And we've gone through the steps involved in creating projects. All right. So like we said, we're not exactly making any assumption regarding what you know. So we're going to go through navigating RStudio. Now you have opened RStudio. Maybe you've got your search box. You have typed in RStudio. You have clicked on it and it has opened up. Then you see the new window and you're wondering exactly, what does this mean? I'm a little bit lost. Where do I go to? I see multiple windows opened up. All right, so basically when you're opening RStudio for the first time, you're most likely going to see 3 windows pop up. 2 on the right, as you can see on the screen, and 1 on the left. All right, so I'm just going to convert my screen to what you're likely going to see when you open up your RStudio. You're likely going to see something that looks like this, right? 1 at the top, right, bottom right, and 1 at the left. this is most likely what you get to see. All right. So let's go through them one after the other. On the left is what we call the source. All right. This is where, pardon, on the left right now that you see is what we call the console. You identify the console usually by having a greater than sign followed by a blinking cursor. All right. That's usually what you get. So this is going to be your console on the left. All right. We're going to come to how do you get to opening two windows on the left in a bit. But let's go to the right now. On the right, what you have at the top is usually your environment. So you can see the things you're working with. Apologies, I think I just stopped sharing my screen. So I'm going to go ahead and share my screen again. All right, so we're here. So what you have usually is this environment. And what the environment does to you is tells you those things you have asked R to keep in memory, all right? Those variables you are working with that you have given to R that, okay, these are the things I'm working. I will see that in action in a bit. And what you have usually for you, if you're just opening, it's most likely going to be the first option here, which is the file option. And you can see, and the file points to the folder that R Studio is currently working with. And then you can see all those files listed in the folder. For me, because this is for this project, you can see everything related to this project listed in that particular environment. All right, so I'm going to go back to my viewer. Of course, the other options are here. You can explore them at your own convenience, all right? We can discuss a little bit further about them. We will have the time sometimes later. But what my own example here has 4 windows.
Hello.
Hello.
Yeah, sorry to break you in. I was actually raising up my hand. So I want to call your attention to a discussion going on in the chat, which is very important. So Abhimanyu Aurora, sorry, don't let me break your name. She's asking a question: when do you create a new project? Which you actually answered well, but this discussion here is not kind of 100% right. That's why I have to come in. A project is not only for scripts. So I want you to clarify that now. It's not just for scripts, no. So clarify that. Thank you.
All right, so thank you very much about that. Yes, Aurora, basically a project is basically that folder that contains everything related to the particular task you are doing or the particular work of interest, okay? Like I said, and like I've shown us just a few moments ago, this is my own project directory, all right? And you can see that there are so many files inside, all right? Including R scripts, if I have any R script, because right now I don't even have any R script in my project directory. That's why this particular folder that I created called R, which is supposed to contain my R script, is basically empty. But you're going to see an example when Bilikisu comes up of how you open up your R scripts and then all other things that a project can contain. She's really going to demonstrate these things. So maybe we can just keep those things conversations till when we start the practical answer with Bilikisu. All right. So thank you. All right. So we'll go ahead. We've looked at the 2 windows on the left. We want to see how do you get to open the 3rd window, the 4th window. We've looked at the 2 windows on the right. We want to see how do you get to open the 2 windows on the left, because we can only see one. Right. So if you come here, you can see a few buttons here that helps you to minimize and maximize as the case may be. And then if I just click on this one, you see it splits my screen into 2. And it opens up this at the top for me. All right. So I have my first windows, 2 on the left, 2 on the right. All right. And the one on the top left, like I said before, is your source window. So it can be used to open a lot of things and not just R script. So if I come to this option here, this white page with a green cross around it, and I click on it, you can see a lot of examples of source windows that I can open here. So I can open a script, I can open a markdown, and I can open a lot of other options, all right? Currently, what I have here is just an R markdown script, all right? An R markdown. So if I just want R script, I can just come here and click on the R script, and it's going to open that for me on a new tab. So basically, this is how you navigate your R Studio. I hope this provides a little bit of basics for our participants today. Right. Okay, thanks a lot, Victor. Yes, I see the contributions on the platform. Please, let's keep the chat box also active. I think it's really going to be an interactive session today for all of us. All right, so we've talked about navigating R Studio. So, and we've also talked a bit about install. So we've installed R, we've installed the R Studio, and we understand exactly how R Studio works now a bit. And so we just quickly mentioned that these are some of the packages we're going to be using today. Basically the tidyverse method package, the lubricate package, and then the schema package. So you can just go ahead. If you are yet to install these packages, I'm sure Bilikis or something might be interested in dropping that in the chat, or one of the hosts might be interested in helping us to drop, or I can just go ahead and drop this in the chat box. All right, so if you have not done the installation, you might just want to go ahead and copy this and run the installation. So where will you paste these things now that you have copied it? You can just basically come to the console here and just drop them there and press enter. Then it's going to download those packages for you. So if I just put them here right now, and I press enter, it's going to go ahead and download those packages on my computer. All right, so why do we basically need to install packages? It's basically because R has a lot of functionalities, all right? And R allows you to be able to tailor what you want to use it for. I mean, to tailor it to meet your own needs. So it doesn't assume that you will need all the packages that are available. It allows you to choose the packages that you want to be able to do the work that you do. Right? That's why it just comes with the basic packages everyone will require, and allows you now to tailor it to design your own R or R Studio environment to suit exactly the type of work that you do. Okay, but like I said, if you have installed these packages before now, you don't need to go ahead and do those steps again. You only need to install packages once, and after you've installed them, they will be available for you, and you can go ahead and use them. Obviously, you'll be needing internet connection to do installations because you'll be downloading online. All right, we're going to come back to packages, but before we go ahead before we get there, we'll just talk a little bit more about functions. So basically, most of your interaction with R is going to be via functions. You're going to be giving R instructions, and you're going to say execute these instructions. The way you give those instructions is largely going to be by writing functions, right? Because R is a programming environment and allows you to be able to produce reproducible work. It generally does not encourage pointing and clicking, point to this, okay, point to that, plot this graph and things like that. No, we generally don't encourage. We say that you write those functions and then those functions will be executed to get the results that you want. So we're just going to go ahead and see a bit of them in action. So I need to also quickly mention at this point that most of your interactions, why do we need a script and why do we have this? Basically, whatever it is that you write in your source up here, you can save them. You can save a copy of them on your computer, and it becomes easy to be able to share that, but not easily so with what you have in your console. So generally, you write whatever codes you want to write in your script, especially for those things you would love to save, and then you get them executed down here in the console. All right, but because we just want to see these ones right here in action, we won't be writing them in our script up here. We're just going to be executing them straight up in the console down here. So you see, I can do my 1 + 1, my simple arithmetic. The plus there is a function that tells how to add 1 and 1. I can just change that to this, which is most likely going to be the commonest form of functions you are going to see. And I can say sum 1 and 1, which is going to give me the same results. So generally, functions have a name followed by an open and closing brackets. And inside the opening and closing bracket are all those instructions you want to give to that particular function. So for sum, for example, I can say something like this, sum 1 and 1, and I'll get my results, okay? I can say sum 1 to 10, and I still get the result of that. All right, so this dot here is just saying from 1 to 10, all right? From 1 to 10 is what that column there is telling us. All right, we've also seen another function that we looked at a few minutes ago when we call the install.packages. All right, we did name the name of the package we want to install, and we gave it another argument by saying dependencies equals true. Dependencies equals true is just saying that, okay, I want you to install tidyverse package, but if tidyverse requires any additional package to be able to work, please also install those packages along the line. All right, I'm sure for those people who have run the script, when you did run the install.packages tidyverse, I'm sure it didn't only download only one package for you, especially if you're doing it for the first time. You most likely downloaded a couple of packages because probably because you did put the dependencies equals true. So it's going to say that, okay, every other packages are also download them along the line. All right, just to also let us know that not all functions have things written inside the brackets, what we call arguments and instructions. For example, a system.date. System.date basically says, what is today's date on my system? What is today's date on my system? So if I do that, I will expect R to tell me that today is 29th of January 2022, all right? And it does that in the year, month, date format. Year, month, date format. Year has 4 digits, 4 characters, 4 digits, month has 2, and date has 2. All right. So we've talked about functions. We're going to be seeing a lot more about functions because, like I said, most of your interaction with R and R Studio will be via functions. Belikisi is going to walk us through most of those ones in the second part of this presentation. So we'll just go ahead and just to let us know that functions always belong to a package, right? A package is a group of related functions. So if you have functions that will do similar things, they are grouped together into a package. All right, and then that's what you get to install. You install the package has functions inside it. Okay, it can be one function, it can be several tens of functions depending on the size of the package. Similar to probably what you already know in Excel, if you use Excel's functions are grouped together and then you can see those group of functions. So the group of functions right here are contained in what we call packages, right? There are some pre-installed packages. I have mentioned this a few minutes ago, but there are a lot of additional packages that you can install depending on what you want to do, right? Basically, you install packages from 2 common platforms. The first one is the comprehensive R archive network, and the second one is GitHub, right? The functions you are installing today, the 3 we have shared with you, you are installing them directly from CRAN. But it's also good to just let you know that sometimes you have to install functions. I mean, you have to install packages, you have to install packages from GitHub. And you can also create your own package. Absolutely, you can design your own package. I know one person on this platform has a package, and Victor Odu, and I have to say that I'm a fan of your Niger package. I use it quite frequently in my work. And I also have the TidyNDR package. So you can also create your own package. And I can tell you that it doesn't take much time before you are able to know enough to create your own set of packages too. All right. So let's talk about assigning values. This symbol on the left that looks, I think it's less than followed by an hyphen or a minus sign. Yeah. So what do you use it for? Basically, we talk about assigning values in R, and that is because you want to be able to utilize values again. And if I take us quickly back to our high school days when we learned about simultaneous equations, maybe quadratic and a few other things like that, we have things like let x equal to 5 and maybe y equal to 10, all right? And then we start saying what is the value of x plus y, x, y minus x, something like this, right? I'm sure you agree with me that you are quite familiar with this. Right, so this is basically what happens when you do this. So I'm going to split my screen again into 4 so that we can see some of the changes that are happening. As you can see right now, my environment is empty. There is nothing contained in my environment. And I'm also going to clear this my console. To clear your console, you can just either click Ctrl L or you click on this broom here to sweep everything away. All right, so I've clicked on the broom and it has swept everything. So my console is also clean right now. So if I just highlight this code and I click on this button called run, I'm going to see that it has sent my x equals 5 to the console. And if I look at my environment window right now, I can see x has a value of 5. All right, so I've given the value 5 to letter x. If I do the same thing with y equals 10, highlight this and I click on run, I'm also going to see that that appears in my environment, the value 10 to y. Okay, so right now, if I do x plus y and send it to the console, I see that R tells me that that is 15. But what if I do a plus b? I get an error. Basically, because I have not I have not assigned a value to a, neither have I assigned a value to b. So that's going to give me an error, right? The same thing if I do y minus x, I get the result. But that's basically not what we're introducing. I'm introducing this sign called this less than followed by a minus sign, but you've not seen that yet, all right? That's basically because we favored, instead of using this equal sign, we favored using the less than followed by an hyphen instead. And that's why I'm going to encourage everyone on this platform to use. If you use the equal sign, you are still likely going to get the results that you desire. But please, generally we favor using the less than sign followed by an hyphen. I know it's a little bit cumbersome, but you're going to get a hang of it in no distant time. So we're going to run these codes again, and it's basically going to give us the same result, right? And then I can decide that I want to assign the value of x plus y to z, right? And I have it this way, right? And then I can send this to, all right. And then I can find another one and call it my age. Don't worry, this is not my real age. So I'm just going to assign a particular figure right now. I'm not up to 50 years of age. So let's just put it at 50. Let's call that my age. Let's assume that's my age. And then I can send this to the console. I just highlight this and then I click on run. And I can see that in my environment here, I have my age giving the value of 15. All right, yeah. Somebody has asked that I kindly increase the font size. Apologies, I'll just quickly do that so that we can have a better viewing experience. Yes, so font size has been increased. All right, and I hope this is better. Yes, obviously, the alt minus will also give you the less than followed by an hyphen sign. So if you want to do that, please just press your alt and minus. Somebody has dropped that for us in the chat, so please you can feel free to take a look at that. So basically, this is assigning value. So if you want to assign anything, you just use the less than followed by hyphen or alt minus as a shortcut, and your value will be on the right. The name you want to give it will be on the left. Okay, so let's go back to our slide. So basically, there are two naming conventions if you want to give name to a value. The two common naming conventions, I apologize. The first one is the snake case. Snake case is everything is written in small letters. Instead of a space, you replace the space with an underscore. No caps, all small letters, every space is replaced with an underscore. That is the snake case. Like I have done with my age here, everything is in small letters, the space has been replaced by an underscore. The other common format is this, what we call the camel case. And for the camel case, it's a few sets of instructions. The first word is all in small letters. Every other word is started by a capital letter, no space. First word is in all small letters. Every other word, you capitalize the first letter there, right? So that's for a camel case. I favor the snake case, and I think most of us on this platform who are familiar and use R or follow the tidyverse format will also favor the snake case. So I'll encourage you to use the snake case as much as possible. I also encourage you as much as possible when you are assigning names. I've done a little bit of XYZ, yeah, but generally, please use meaningful names because you really don't know exactly what X stands for, what Y stands for, or something like that. But if I use a name like my age, I will easily remember that, oh, I'm referring to my age and not Bilikisu's age or anybody else's age, all right? So please use meaningful names as much as possible. And also know that you can override previous names. So if you don't want to overwrite a value, then you also always have to give it a different name. If, for example, I already know that my X is, I've assigned it to a value of 5. If I come down here and I change that value to 20, it will just override the initial value of 5, and I'll lose it until I go back to reassign it. It won't even give me a warning or something like that. So please be aware that you can easily override a value, the value of, you are assigned to a particular name, and that you also can write comments. You can put comments in your code or anything to be able to define. So to be able to provide some clarifications or guidance. So I can just come here and say, okay, this is what Stephen's age, all right? And then any word to the right of the pound sign is ignored by R because it assumes that you are just writing some comments and providing some clarifications for the user. That belongs to the users. It really doesn't belong to the computer, all right? So the computer ignores anything to the right of the pound sign. Okay. All right. So we're almost done with this particular session, and I hope you're finding it interesting so far. We've used a few arithmetic operators. We've used the plus sign, we've used the minus sign, but just to throw this out there, I will basically won't be going through all of this to let you know that these are the other common signs. A few ones we're probably more familiar with these first 5 ones because practically every language or every application use the same as the same way. But a few other ones like this, and then we can have the greater than or equal sign. If you want to check for equality, you use the equal sign. If you want to check for something not equal, you use the exclamation mark followed by an equal sign. So we can just check out those two right now. So I have something like this. I can say is 6 equal 3 times 2. All right. We know that what you have on the right side is 3 times 2, which is supposed to give you 6. So yeah, 6 is supposed to be equal to 6, right? So we expect to get a true here because we are checking for test of equality. And so if I send this to the console by running this, I see that I get my result that says true, all right? And then if I change this from equal and I say not equal, okay? Exclamation mark followed by an equal sign, I will expect to get a false because 6 is actually equal to 3 times 2. So if I highlight this again and send it to the console, I'm going to get my false, all right? So that's just, I know that not all languages have a test of equality or inequality exactly the same as this. So that's just why I'm using that as an example. Again, you'll be getting to see the slides. So feel free to, when you have the slides, look through the other ones. These are not exhaustive, but I think that these are the more common ones that you're going to be getting to see. All right, so I hope I've not lost our participants, and I'm just really going to do a quick recap, and then if you have questions and comments, you can take them after that. I know we have already addressed some of the comments and questions along the line, but just to put it out there again, that please, R is free and it's versatile. You're welcome to use it. I have been using it for 7 years, and I've really not stopped since then, all right? R can ingest a lot of different types of data and actually can communicate with several other analytics softwares. R communicates excellently well with a lot of other analytics softwares, the ones you are quite familiar with. I am almost certain that R communicates with them, all right? And to also let you know that data is not always tidy. In fact, data is not usually tidy. and that you might need to be able to do some manipulations to get it in the tidy format. That makes analysis easy and for you and gives you a wonderful analysis experience. Please use as R project as much as possible if you are going to be working on a set of analysis for a particular work. So one project for each work you are doing. It's encouraged. It makes your experience a lot more user-friendly. Your interactions will likely be through functions in R. So you will get to see a lot of functions today. Every function belongs to a package. And it's also useful that before you can, to know that before you can use a function, it means that you must have had the package where the function is found installed on your computer and loaded into memory, right? Two things are involved to be able to use a function. The package must be present on your computer, one. Two, the package must be loaded into memory for you to be able to access and use the function. You're going to see how Bilikis will walk you through loading packages into memory in a bit, right? And then don't forget that if you want to save an object in R, please give it a meaningful name. Use the assignment operator less than followed by an hyphen. It's going to make your experience a lot better, and it's going to make sharing your codes with other people more seamless too, if I may put it that way. And also, you have seen the common arithmetic operators that you're going to be using, right? So I think this is basically the last of my presentations. Please, if you have any questions for me before we go to the second section of this workshop. Thank you. Do we have any questions that I have not I'm yet to respond to on the platform, or does anybody else have any question they would like to ask at this time?
All right, thank you. I think someone is raising his hand. Aurora.
Yeah, thank you. Thank you very much, Stephen. It was really a fantastic session. I really learned a lot. I just have one small question. In the console, I do not see this render tab. I see like you have a console terminal. I also have console terminal and jobs, but I don't see render tab in what you have in the console.
Oh, yeah. Okay. That's an excellent question, and thank you for noticing that. I do really appreciate it. All right. So I need to also let you know at this point that what you see as tabs in your windows can vary depending on the work you are currently doing. All right. So beyond not seeing the render, I probably just want to show you one more thing that you probably didn't see. If you look at the top right window here, you probably don't have Git, G-I-T, right?
Yes, exactly. Git and tutorial both are missing in my case, exactly.
So it depends on what you are doing and sometimes the other add-ons that you have installed onto your platform, right? So why I have a render here is basically because I have rendered my slide. Okay, so this is my slide. This is the code that actually generated my slide, and I have asked R to compile or render the slide. All right, so it's because I am seeing these slides right now. That's why I have the render. That's why I have the render tab here. If I stop sharing this slide and I close this window, the render is going to disappear. I hope that clarifies it for you.
Yes, thank you very much.
Basically, the same thing goes for the Git tutorials and the rest of them. It basically depends on what you are doing, and you're going to see that these things can change over time. You can also customize, because it is not impossible that I might have customized some things too. But basically, I love going with the default settings, except changing the color appearance. Every other thing is the default. Thank you for that wonderful question. Do we have any other question for me?
Hello, please, if you have any question, you could please raise your hand, please.
All right, I see one question here sent by John to me directly on the chat platform. I'm going to copy it from the and put it in the chat box so that everyone can see. So John is asking, how can we apply R in banking operations? So I need to also let you know, excellent question, John, thank you. To let you know that there are a whole lot of people within the finance industry that are using R. There are a whole lot of ways that you can apply this. You can reach out to Abuja User Group, or you can reach out to any of the co-host, you can reach out to me and we can probably just point you in some useful directions. But there are so many resources online as to how people are using R in the finance world, and I think you'll find them useful. Thank you.
All right, thank you very much. In the absence of any questions again, so I think we can move on.
All right, so thank you, Fidelis. I'm going to go ahead and stop sharing my screen now, and I'm going to hand over to Bilikisu, who is going to take us through the second part of this workshop today. Thank you.
Okay, thank you so much. Okay. So, oh, sorry, can you see my screen?
Yes, we can.
Okay, I'm seeing a question here. Okay, like a comment. So all the resources for the class, they're going to be shared after the program. So don't worry, we'll have all those shared with you later. Okay. Okay. So without wasting much of our time, thank you so much, Stephen. You've done a really great job setting the pace. So I will go ahead now and start my session. So my own session, the part 2, is going to be based on importing, manipulating, and analyzing data in R. So, okay. So a brief recap of the part 1. So Stephen has done a wonderful job taking you through the working environment, which is essential for the project experience, a good one. So then we've also interacted with R. So you're a little bit more familiar with R now. So then also you have an understanding of the tabular data. So for this session, I will be importing data with you. So although I'm not going to go through the web, but I'm looking at working with the local data. So we're going to talk about all the other sources as well, but we might not be able to go through that because of the time constraints. So we'll look at managing different file formats. Then we'll dive down into data cleaning and transformation, then basic analysis, as well as data visualization. So the data we're going to be using today is going to be data for Africa COVID-19 data set. So the columns that are available here are the countries / region, which is the country that is reporting the data. So then the date that the report was generated, then the confirmed cases, as well as the number of deaths, then those who recovered, the number of people who recovered from the case. So we're going to look at organizing the project directory. So we look at how put your data in different folders, then you keep your house script separate, then you keep your outputs in a different folder as well. So it's all about reproducibility of your codes and your structure, basically. So we'll go into that. And that was what we were trying to kind of resolve the other time in the part 1. So I'll share my RStudio code, then you'll be able to understand what really goes into your project. So I would stop sharing this, then go into. Sorry, sorry for the break. I had to attend to a baby here. Thank you. I'll share my screen right away. So I hope we can all see my screen.
Yes, we
Hello?
can.
Okay, thank you so much. So I want to start from the project setup. So this, if you can look at my screen, from what Stephen has really tried very well to explain to us, this is the project folder that I'm going to be using today. So the same thing as what Stephen used, but I've created another folder within the project folder. So that's for the data. So what I'm going to explain here is that, yes, your project would have scripts. That is the primary thing that you expect to be in your project folder, but you can have so many things there. So I will use this time to really explain that. So if you look at my screen here, there are so many things inside the folder. So you can see we have different type of scripts that we have here. Then we have the CSV file. There's a CSV file here that is outside within the main folder. Then we also have images. We have, okay, yeah, this is the folder for the images where we have different images that were used in the slides that were used for the presentation. So we also have CSS files. So we have library, which is having some other files that we're using for the presentation. So basically your project can contain as many files as you want. It can even have a database script or file that you can use within your project. It depends on what you need for your project. So it doesn't have to be just scripts. So that is basically what we're saying. Yeah, we are right to say we have scripts in our folder, so many lines of codes, yes. But there's more to the project than just the script. So thank you so much for all those who contributed to that discussion in the chat box. So I'm going to start with the packages that we sent an email to you. We asked you to install some packages. So I'll start with installing those packages. I'll show you how we're installing, just like Stephen has rightly shown you. So, but I'll start again by just adding it. So what you just need to install a package, you can either type in the script and put the name of the package you want to install in the double quotation. Maybe I'll look at tidyverse. So now this session is basically about typing and writing the script. So I'll be as slow as I can. I'm not going to get you lost. Just follow along. So we're going to share the script later. So just focus on my screen and we'll be good to go. Okay, so for us to work on importing our data, manipulating our data, analyzing it, and visualizing the data, we need some packages. And the first package that we're going to use here is the tidyverse. And that is what I'm showing you how to install now. So you type in this first line of code. This will help you to install it. When you put your cursor there, click the run. Or if you don't want to start typing a lot here, although our studio is going to help you with the intelligence, but you can also go into one of these pane here. So the file pane here, you'll see there's a tab with the name packages. So you can just go here, click on the install button and type the name like tidyverse. Okay, then you click install. RStudio will install it for you. So I already have it installed on my system, so I'm not going to be installing this now. So the second package was the Lubridate. So if you put in the Lubridate package, I have that installed, so I'm not going to do that now. So then the third one, Schema for exploratory data analysis. Okay, you need to put that in double quotes. Okay, so that is that. So I'm also not installing this because I have it on my system here on my RStudio installed already. So after the installation, the next thing you need to do for us to be able to use the packages, we need to load it into RStudio's environment. So anytime after installation, you only need to install once for your RStudio installation. So you might want to update, just like you're seeing in my screen here. The packages tab allows you to install as well as update the package that you've already installed. So you can select any package you've installed before, then update it. Maybe there's a newer version, you got the email or newsletter that this has been updated, then you can always update it. So for you to use it in the RStudio environment, you need to load, to load your library, but you would have to use this function library. Okay, you have to use the function library to load the package. Okay, I hope I didn't get you confused there. So that will be, I'm loading my tidyverse package. So you can click on the run button to load it. So as I'm loading into the RStudio environment, you can see we have so many packages. Then one thing is this, there are packages that have other packages within them. So tidyverse is one that is common. It contains so many other packages. So these are the other packages that is displaying here in the console. We have the ggplot2 for the visualization table, the smart table. So tidyr for manipulation, for tidying up our data. Then the readr for reading our files into our RStudio environment. The pour, iteration, dplyr, manipulation. Then the stringr for manipulating our strings. The forecast for categorical values. So all these are the packages that are within the almighty tidyverse package. So the next one package that we're going to be bringing into the RStudio environment is the Schema package. Then I don't want to forget the Lubridate package. Okay. So we have the Lubridate package. Although the Lubridate package is supposed to be one of the data in the packages in tidyverse, but it has not been combined with it yet. For now, I'm not so sure. Maybe somebody can correct me there, but it's still, you have to load it outside of tidyverse. So now I have my RStudio ready for me to start working now. So the next thing I would have to do now, before we go into the exploratory data analysis, we need to bring in or read in our data. So while working with data can come in any type of format. So it's not, we're going to be working with CSV today, but it's not just CSV files that we have. We have Excel, we can bring in Excel files, we can scrape data from websites. So we can go to, let's say, our own NCDC website, we can go there and scrub or web scraping the daily COVID-19 cases on their website. So if you want to get data from there every day, we can do that, write a script to get all those data, and we'll format it and put it in a tabular format. So that is beyond the class today, because we are looking at those who are just coming into R. So we can work with so many files. We can work with XML files. We can work with databases, Spark, or there's so many the big data names. We're not going to go into all those big terms. So we're looking specifically for this class, we're looking at bringing in CSV data. So it's that's comma separated values. It's in that as simple. So you can view this data in Excel as well as we can bring it into our studio. So now that's the first thing we need to do here. So I'll give it the name data. So I'm going to use the equal sign of the assignment operator here, like Stephen explained. So the first thing is that from my console, I'm going to be using the first package within tidyverse, which is readr package. So I might be using a function that you don't know where it's coming from, but immediately I'm typing, the IntelliSense from RStudio will help you to figure out where is this function coming from. Just like Stephen explained, a package has so many functions that you can use to achieve your goal. Maybe you want to analyze, or you want to get data into, or you want to visualize it in RStudio. So that is that. So also, one other thing that I want to highlight here is that it's not just readr package that we can use in bringing in data into an AR environment like RStudio. We have other packages. We have Rio, we have VRoom, so many packages out there that we can use to read in our data. So, but if you're starting right, just like the title for this webinar states, if you're starting right, start small, start simple. And the simplicity starts with the tidy packages that we're having. Understand that for you to be able to get a good starting, you need to follow the tidy principle. Follow the tidy principle and follow it in a smart, simple way. That is just what we'll advise. Start simple, smart, and build on your skills gradually. So let's start, we're starting with the tidy mentality. VRoom is also based on tidy mentality, but we're starting small with the tidyverse. Let's just keep it at that. So using a package, you can type the name of the package, okay? Then followed by the double colons. So like you see on my screen, you follow with a double colon, then you'll be able to access all the functions that are within that package. So that is one option there. So if I type, so after this, now let me put the second one. So I'll read, so I want to use the read_CSV function. That is the one that I'm going to be using today. So when I type that, it brings it up and displays it in RStudio for me. Mind you, we are using packages now, but R has some base functionalities that you can use, like utility functionalities, that functions that are within R. So those ones, it's still okay to use them, but there are some packages now that are kind of better off in terms of speed and the community support. That's basically what I can just push, but it's not that it's not useful. There's still so many base functions that you still use. You still have to use them. So that's on that note. So when you have your functions here like this, there are some parameters or argument that you need to pass to the function. So that is, if you press your tab key, while your cursor is in the brackets, just press the tab key. It will give you the options, the arguments that you need to supply answers to or values to, so that it will be able to perform its function. So the first one is the file. Where is your file located? And that is when we're talking about, you have a project folder now. Your file, your data file should not be outside your project folder. It should be within it, so that you don't go looking at, okay, maybe you now share the folder with somebody and the person is trying to run your script and voila, he got into a problem. There's error, file missing or something. The person couldn't even comprehend what's going on. That means something is missing here. So you wouldn't want them coming back and forth to you that, okay, something went wrong. So it's better to keep all the files necessary for your project in the same folder. So data, images, and just put them together. That is better. So now the value here is going to be, so I'll use the tab key again. So if I use the tab key within double quotation, it's going to help, it's going to go immediately into my project folder, not outside my project folder. That's the first place it's going to look at. So now you can see I have a copy of my CSV within the main folder, and I also have one inside the data folder. So if I press tab now, that's the only file obviously there. So if I show you here now, you can see it's there within the data folder. And that is a good way to arrange or organize your folder, your project folder or repository, whichever name we want to give it. So this is the starting point in getting our data into RStudio. So this is a starting point, but as you go outside, if I run this line of code now, so in my console, you can see I have my data now. And another thing you can see here is that in the environment, I have an object under the name data. So it's already here in my environment. That means it's a named object that is saved within my RStudio environment that I can work with. So as you're moving on, maybe you might be reading tutorials online, you might see something different from what I have here. So they might go this way, data, then I assign it, I said read underscore CSV. Okay, so I put in the double quotation. Okay, so you might see a shorter version of what I have here on line 12, like this, online, maybe while reading a tutorial, is because the package name here, RStudio already recognizes it because it's within the tidyverse package. Okay, so you don't need to repeat yourself. That's what's saying is that, okay, I already know you have a package by this name here. So you don't need to tell me again to use it. So you can just go ahead and call the function. So when you call the function, I already know where to pull that function from. So if you look at when I'm typing, let me cut this out. So if I say read, because the first one that is popping up is the base function, which you can still use. But when I now put the underscore, you can see the name that is giving me, the options here now are this. So, and on the right side of each of the function names is having another name in a curly bracket. So that is the package name. So you know where it's coming from. So you don't need to add or precede it with the package name again. So as far as I'm typing now, I might not be using or calling the package name before I use the functions again. So I think, well, you're getting to be an R user now. So that's that. So I'll take out this line. And okay, let me just leave it there. Okay, so it's still the same results that we're going to get. So the ways you can view your data after bringing it into RStudio, you can see there's a summarized information about the data. Then you can also go into the environment, click on the name of the data, and you have a view, just like Excel. You have it displayed to you. Immediately you click the name. So you have a look like, okay, something similar to Excel sheet. So you can see everything within the data, and you can also see that it's showing you 1 to 35 of 39,636 entries with a total of 5 columns. So all this is what you can see here. Excuse me. So that's basically that. So now, after getting your data in here, let me put it, data. So you can also type data, then Control Enter. So you also, if you run, put your cursor there and click the run button, or you click Control Enter, you will have it display a shorter version of it, of what you saw in the window. You see it in the console. So you have the same thing, but here you can see each of the column has something on top. Okay, after the name, you can see the first column is a character type. Then the second one is a date column, but it's a character now. It's a character. So then the second one, the remaining are double. That basically they are numbers. So coming back to the environment, if you click on the arrow beside the data, you will be able to see something about it as well. So you will see the character, then the numbers. So it's not double now. So within the console, it was double. Then now it's numbers. So you will see the values that are there. So the date that I'm telling you that, okay, it's now character here in the console. You can see the, just like Stephen explained, anything within double quotation or even single quotation, sometimes you can have it that way. It's a character. It's a character, even if it's number, if it's date or something, that is when you have to go an extra mile to do what? To manipulate your data. You have to transform it. So, okay, yeah, you brought it in as a character, but I want it in date format. So that's something you have to do there. Okay, so now let's do some. As somebody writing our code, you're working with data now. So you need to do some little exploratory data analysis. So we call it short form is EDA. So we need to have a look, just like we're looking at having a look at our data, we can use scripts to have a look at our data. So first thing, there's a function called head. It's a base function, the basal function.
Sorry, ma. Sorry,
okay.
ma. Somebody's asking a question. That's if we are going to have the data sample we are using.
Sure, we're going to have it. Everything, just like we're packaging the folder now. Immediately we finish the webinar. If you're registered on the Meetup page, we're going to share it. We're going to share it with you on the Meetup. And also we're going to share it on our LinkedIn account. So we're going to share that. Then you have the video on our YouTube channel. I hope I answered the question. Hello?
Yes, ma'am. Yes, ma'am.
Okay. Okay, thank you. Okay, so for using this function, we'll put in our data there, the tabular data that we're having. We want to look at what it's going to do for you now is that the function is going to give you the default first 6 rows of your tabular data. So if I put in the data now, then I run it. So it's showing, popping up the data, the tabular data. And if you see data, so you can see there's a box like a sheet before the name data. So that's showing you that's a tabular data. So it has rows and columns. So if I run this line of code now, I'm going to get the first 6 rows of my data. So that's the first one, the first 6. But if I want to extend it down, okay, I want more than 6. So I will go ahead, just press the tab button. There's another argument that you can give it. So you can give like this. So it will return the first 10 rows. Then the opposite would be maybe the last 10 rows. So if you have head, then the opposite will be a tail. So tail gives me the opposite. So the last 10 now. So that's the last 10 observations from the tabular data then. So the next thing you have to do now is that, okay, I've seen the beginning and the end now. You can use some other functionals like dim. So if I put in the data, it's going to give me the number of observations there. So I have 3, so now I have 39,636 observations. Then the second value that is giving me is the number of columns. That's 5 columns. So that is that. So the next thing now, after doing this, there's another functionality that you should get used to. So that's the glimpse. So it's from the dplyr package, which is also part of the baby packages that are within the tidyverse. So if I click on this and I have data, yeah. So I click the run. So, okay, let me just clean my console a little bit. So what Glimpse does for you is that it gives you a much more better view of your data. So now it's telling me, okay, you have rows. This is your number of rows that you have in the columns with specific names. So I can understand better. I don't have to guess like what dim function did for me. It just gave me the number. How do I know it? The first one is number of rows and the last one is the column, number of columns. So, but this gives a better view, better results or output than that. So now I know I have 5 columns, then the character, the type, then the first view, a few values or observations within each column. So moving on now. So as a data analyst, even for the question that was asked, okay, how do they use it in the banking industry? We're working with data here. These are the things that you can do. We have things that are common to each industry. Exploratory data analysis is common to all sectors. You need to explore your data. So that is just some of the things that they do in the banking industry as well. So the next thing is we're looking at the Schema package. So there's a function in Schema package that allows me to have something beyond the glimpse, what the output that I got from glimpse. So if I put in the data now, so it's an argument that data is equal to data. So I just want to, let's work the way you see it outside so you don't get scared there. So this is a statistical summary of my data, the entire data now, the data set. Although we're still going to get there, before I would want to do this, I might want to kind of do some cleaning with my data, especially the date column, something, but it's still okay. It's just having an idea of what this functionality does for you. So here I have everything like the number of rows and columns here. Then the column type frequency. How many times do I have character columns? So 2 times. The numeric has 2 and 3 times, occurred 3 times. So we have 3 columns that are numeric in nature. So type there. So group variables, there's none. So also we are we're now going deep into the variable types. So let's look at the character types first. Do we have any missing number and values? None. So the data is complete. That's the complete rate. That's what it's telling you is 111 now. That means it's complete. So then the minimum value here, it's giving me 4, which should mean that doesn't the number now. So then we have maximum values, number of unique values for the country, especially the country is 54, then date is 734. So we'll get to see that as we do some manipulation later. Then the numeric values, this one now makes sense more if you are starting new. So now you will be able to have some statistical functionality that you would perform as a maybe a statistics professional or something. But as anybody working with data, you need to, okay, let me understand the average value that is in this numeric column. So no missing number, no missing values here, then it's complete as well. Then these are the mean, the average value for each of the columns, then the standard deviation. These are some values that I don't want to go so much into, but we're going to have another webinar that will deal with all this. So all are values that statistical professionals would understand, but here we're looking at getting started. So I don't want to go outside of what we're supposed to deal with. So now the next thing, there are other packages that you can use for EDA. There's another package we call Data Explorer. That's a fantastic package as well that you can use, but let's start simple. We're starting simple here. I think we've gone a little bit further with even starting simple. So I want to explore the Tidyverse package. So the Tidyverse package has a lot to do with helping you getting started well. So it helps you in a lot of ways. So the packages that we have within it, just like we had when we loaded the package, we have those ones that help you to get your data in, those ones that get your data, the tidy, into the formats that is tidy, in the tidy sense. So we also have those ones that help you with characters that are supposed to be categorical. And we also have packages that helps you, maybe you're working with strings and you have strings that are kind of long and lumped together. You have underscore there. Maybe we have, okay, maybe a name now. A name. You ask somebody who is filling a form to kind of fill their form, full name. We want your full name. Now you now realize that, okay, we need to have the first name and the last name separate as a variable, that is a column, separate columns. So we need to break this full name into the last name and the first name. So basically, maybe it's a space that is between the first and the last name. We need to split it. So that comes where we use the string out package. It helps a lot in doing that. So, and those ones for the dates. So it's a lot that the tidy package does for you. So let's start with that and look at some of the things that you can actually do working with Tidyverse package. So we'll start with the dplyr package, I suppose. So here we're going to look at how do we select specific variables or columns in our data set. So this is where you'll want to use the select function, which is from the dplyr package. So let me put the name here. Dplyr. Okay, it's coming up with the now. Okay, I'll put a comment on that. So here, this function helps us to make selection. You might have more than 5 columns in your data, your tabular data, but you don't want to use all. We don't need all. Maybe, okay, I decide to, okay, I have like 50 columns or something, or 20, whichever way, but I need like 5 or 10 specific columns that I needed for my analysis. So I don't need to bring in everything at the same time working with them. Might be kind of not so an efficient way to work. So now I can look at using this function. There are different ways that we can use them. I can see some chats going on there. Do we have questions at this point? Maybe I should entertain questions. Any question at this point?
Maybe Biliki, so I have a very basic question.
Good.
When I'm trying to install a package, when I use this option dependency equal to true, there it shows an error. But without that option, it is able to install. So is it okay if we install the package without dependency equal to true?
Okay, I'm muted. The dependencies, you can allow RStudio to download those dependencies for you. There's sometimes it will pop up, okay, there are some dependencies that you need to, it might be in the console. Sometimes it might be in the console and displays that, okay, it can't install this because of these dependencies. Then you either install it yourself, or you allow RStudio to install for you, then it will also install the actual package that you want. Does that answer the question?
Because when I'm when I'm putting in that option, dependency equal to true, then it is showing an error and it is unable to install this package schema. But when I just install packages schema without that comma dependency equal to true, then it is successfully
Exactly.
installed.
So now I get where you're going. For what we just displayed now, you're not supposed to add in dependencies. If the package actually needed you to install some dependencies, it will install. It will tell you. You don't have to specifically say that, except maybe you've been told, okay, if you want to install this package, you need to put these dependencies there. You don't have to do that. So that's why you don't need a dependency to install tidyverse. No, the same thing goes with Lubricate. If you needed that, we would have said that.
I see.
I hope you're okay.
Thank you.
So just to say, I know there are some functions like, okay, I'll give you an example. For the read, okay, an example is this read underscore CSV. If I put a comma now and I press tab, there are other arguments that I can pass in, which actually I don't need it to start working with read underscore CSV function of the reader package. Okay, but as time goes on, maybe I'm bringing in data and I'm getting into trouble. Then I have to explore other arguments that are within the functionality. Okay, so but starting simple, I think that's better. So for the column names, if I can use that, if I want to tell, okay, yeah, there are column names in the CSV, so don't bother, I already have my column names there. Or like what we encountered in the date column, we can decide, okay, this column type, I want to specifically tell read underscore CSV, hello, you're bringing in the data, and I know you might get confused along the way. What you need to understand is that country / region is character. The next one, date, is date, not character. So the other ones are numeric and numeric. So you can do all that. Okay. So that is basically that. But to start simple, the default argument that you need to pass to the read underscore CSV is the file. So when I get into RStudio and the data gets into RStudio, I can do other stuff that I want to do with it before I make any insight or analysis with the data. I would have to manipulate first. So, and I think Stephen showed a picture that was that Adli we can usually share, the workflow for you to work with data. So manipulation is a key aspect of what you do. And that is, and he also mentioned that, okay, it takes a lot of the workload, the power or something that any data analyst or scientist or engineer does. You have to manipulate your work, clean it, get it into the right shape. You can't get a clean data always. You can't. As clean as this data, no missing values and all this stuff, it's still giving me something wrong. The date column is not in the right format. So you can't get 100% clean data. I'm not good. If you're going to get clean data, then that means somebody has already done the work for you. That's it. So that's basically that. So any other question before we move on? Can I go on?
Yes, please go on.
Okay, thank you so much. Thank you. Okay, so now we want to explore this function, select function. If you press the tab key, the first argument that you need to give a value to or something is your data. So, but before I go on, let me introduce a functionality called pipes, the pipe function. So we call it pipes because it's actually work like a pipe. So that will be Ctrl+Shift+M. So for you to get this like the icon or something, this operator, you have to use the Shift+Ctrl+M, or you type in yourself one by one, percentage greater than, then percentage. But the shortcut is for you to press down the Shift+Ctrl+M. Then you'll be able to get that operator there. What this operator does is that it helps you to, like a pipe, or maybe in an airport, you check in your bag, it takes your bag, it passes through kind of like a rail or something that, okay, takes your baggage to another section where it's going to be checked and maybe examined before it's now taken to another section before it gets onto your aircraft. And you might not even get to see your baggage, maybe on any stopover, it just goes on like that. So any transformation from one stage to another, the pipe helps you to carry the output or the result of that transformation to the next level. That is what the pipe functionality does for you. So I'm going to bring it in now to make our work kind of neater, the code neater. So instead of using the select function, or you can do this, I say data. So then the next thing will be what you want to put in there. Select what country. I think we should have our data here. Okay, I think I should be able to see that, but I don't know what's going on. So I think that's live coding for us, but I'll go with my pipe. So I'll say that's data. So I'll go with my pipe, then select for me country / region. Okay. So now one thing I want you to understand is this is kind of a complex naming. Is you won't be able to get anything if I say comma and I said okay, you might get into trouble because it will throw an error. Okay, so it's going to tell me that, okay, this doesn't exist or something. It's not about, okay, I typed something wrong here. Okay, let me go through that again. I'm praying the okay, good. The IntelliSense actually worked. So I was actually the person that typed something wrong there. So for any complex, maybe naming, maybe there's a space in between the maybe like, okay, full name, and now written is now written as something like the name of the column now is now full name. So this is going to give you an error as well, because there is a space in between the name. So what you have to do is just select it and put it in this specialized quotes. That's the key, the first key on your keyboard under the escape key. I've kind of lost the name now. So because the space is not okay within the name of your column, so it's going to give an error. So it doesn't make sense using it. So you have to put it in this quotes. And that's what RStudio has done for me. So now I want to select the country or region, then the date. So with this now, if I run this line of code, so it's going to return only the country and the date column for me. Okay. So another thing that I can do with the select function, I'll copy this, place it here. So I can also do like a range. Let me put the column here, a colon here. So I will, now what I'm saying is that give me all the columns from country/region up to death. The death, okay, I think that's kind of scary for me. So let me go for confirm. Confirm. Okay, I think this is okay now. Okay, don't mind my child with that too. Okay, so this is going to give me the range now. So that's country, date, and confirmed column. So with all the rows now. So, and that is that. But if I'm now looking at, okay, I don't want to have all of them, but I just want to, okay, take out some. Yeah. Let me just, okay, I've done that here. What are other, okay, there are some functionalities that you can use in select function. There's another function. Okay, let's say, what would that one go with? Okay, let's say you have so many columns that are starting with C. We have like maybe confirmed underscore recorded or something. Maybe you want to all the C's, all the columns with C's. So you can say start, I think starts with. Okay, so we can use this and put it in double quotes. Yeah, then C. So this will give me something like this. Yeah, all the C's. So that's country and confirmed cases. I hope that, so if I can do the same thing. Okay, yeah, we have two D's there. So we can put D there. So that's it. So there are so many things there. I think there's another functionality ends with, and so on. So just explore that so that we don't take much of the time. So then another one, we can filter. So filtering actually works with the observations. So I'm trying to look at, okay, I want only observations or rows that are having recovered, or maybe let's look at confirmed cases less than 10,000. Okay, so that will be data. Okay, select. We're filtering now. Filter. Okay, so I would say, let's say confirmed cases now. I want it less than 10,000. Okay, so Okay, these are the ones with, so you can see the confirmed cases are all less than 1,000, all of them. We can view it, if you want to view this, the results that you're having in the console, you want to view it in your, like an Excel sheet, you can use the function view with a capital letter V. So it's going to take us to the window where we see it. So these are all, so you can look at it all down, the confirmed cases are all less than 10,000. Okay, so they're all less than 10,000. Okay. So, okay, so that's that. Okay, then there are other things that you can do with it. Let me go find another example, then we'll move on. So we can filter. So which other values are we looking? Okay. Okay, I can use the confirmed as well. Confirmed. Okay, confirmed. I use the functionality between. So between, there's another function that you can use within the filter functionality. So that will be confirmed case, let's say between 1,000 and 5,000. So don't forget, you can see there's a red button here on the number, on the line, that script line, the code line, telling me that something is wrong. So always remember to check if something is like, Aurora very smartly recognized that, okay, no, your screen, your tabs are different from mine. Why is there a difference? That was smart. So you should be very, very careful. Look, like we say here in Nigeria, the Lagos, sharpen your eyes. So you look very carefully, be aware of your environment. There's something going wrong here. So before you start screaming, oh, this thing is difficult, it's not difficult at all. RStudio even helps you better to understand. It's helping you a lot. So this now is telling me, unmatched opening bracket. That means I'm missing out on a bracket. Is that the opening bracket or the closing one? So definitely it's the closing brackets now. So immediately I put that there, it's now understand, okay, yeah, you did a great job there. So it's gone. So if I state that now, so I have the confirmed cases is going to be between 1,000 and 5,000. Let's go and view it in the window then. So I run this. So for everything here, they should be between 1,000. So you look at them. So everything, the confirmed cases. So it's just for you to explore. So there are so many opportunities for you to do a lot there. Okay. Okay, I think this should go up here. Okay. Okay, so I hope there's no question at this point. I'm doing a lot of coding now. So if there's any question. Okay, that's great. Aurora, maybe I'll teach you a lot about the slangs or the what we use here. I'll teach you some of it. Thank you. So any question here? Any question? Thank you, Oluchi. Thank you. So any question at this point? Should I go ahead?
Please do.
Thank you. Okay, so I think we've done a lot now. So before we go into, I think that data visualization, let me do some cleaning up. Like we already recognized that the dates column is not in the right format that we want it. So what I'm going to do now is that I need to, any question? Okay, thank you. So what we need to do now is this. We have to use some new functions that I'm going to introduce that we call them mutate function. So it's also within the dplyr package. So all I need to do, I'll use my very, very useful pipe. So data now, yeah, my pipe. So I come down here, just press your enter to bring you to a nice spot there. So I want to manipulate the data column, the date column. I don't want it in character. I want to change it. So this function helps me to do that. So all I just need to do is that I already have my data before the pipe. So my data is going to be, sorry. Okay, my data is going to be pushed into this functionality, and whatever variable that is there, or whatever I want to do with it, I'll be able to do that within this function. So I'm going to take the date column first. Okay, so is equal to, so now this is where I use the Numeric package. Numeric package is going to help me a lot in transforming my date columns. So if this is the package name now, if you look at all of the functions here, they are all dealing with dates. Can do a lot with what we have in here. But I don't want to take you too much off track. So we're going to go in. So I want to use, okay, which function would they, okay, now the first thing you have to do, look at the dates. Now I can see that the dates, I think the first value here is the month, and this is the day, and the last one is the year. So there is a function in, yeah, in Numeric, that's that would be month, yeah, D, Y, yeah, it pops it up. So this will help me to change it into a date format. Looking at the structure of the value there, actually. Excuse me, I want to take water. Okay. Okay, so now, excuse me. So I'll put in the date value here. So what this is going to do is that, okay, my date column, this is the name, but now I want you to change everything in this date column to be equal to what is on the right side now. So whatever was in my date column before is now going to be replaced with what is on the right side. So another thing you should know, starting well and the right way, is that you can select this now and we'll run it. So can you see what is on my, okay, let me clean this up a little bit. We need some space there. So if I run this, okay, I click on run. Okay, if you see the output now, look at the output. Now I have the country as character, and now the date column is no more a character, is now date. So it has helped me to transform it from being just an ordinary character now into a date format. And this makes sense, especially when you're doing something like time series analysis. You need your dates, so you can't work with character at all. So in that kind of instance, so that is that. So now this data is no more going to be the way it was before. Now the column, date column, has been changed, has been transformed or manipulated now. So that is that. So the next thing that I want to add another pipe. This. Okay. So what I want to do now, the next thing that I want to change here, because I'm looking at taking us to the visualization aspect of it. If you want to do something maybe you want to create a visual, you need to know the type of values that you're working with. Most of the time, character values might not be so useful when you want to visualize. It's better you turn them into categorical values. So that will make sense and help you a lot to do more with your analysis. So that is something that I'm going to do now to save us some time here. So I can do that with mutate again. Country. Okay. So is equal to underscore factor. Okay. Another function that you can use is also factor. So instead of this, you can use factor functionality. So I will just put in the country. Okay. So if I run this, so you can see now it's been transformed into a categorical, is a factor now. So that means it's like a bucket that is unique. We should be able to identify you. If you're Nigerian, you are a Nigerian. If you are from India or Pakistan or South Africa, United States, you should know that, okay, you are who you are. So that is the category. We'll put you as a category now. So that is basically that. So another thing, okay, what else can we do? Sorry, excuse me. Okay. So now the next, sorry, the next thing we'll be looking at is this is it. So when you're doing your data manipulation, we need to look at a way of saving the data. So data, we can save data cleaned data. Okay, so we will do clean data. So we can decide to save this. So you have it and you have it in your environment. So that might be what you need now. But another thing that we can do is this. We need to look at the uniqueness of our data. Are these data unique? Because when you want to analyze, you might have to look at summarizing your data first. So if I have Nigeria repeated like maybe 10 times in the data, is there any way that I can make sense of it by just having only one Nigeria and make it summarize value from the other variables that are available? So this helps a lot. So I'm going to show how to do that now. So we'll look at grouping data. So we want to look at grouping data now. So here we're going to look at how to group data. Then you have to learn how to also ungroup the data, because after grouping, all the groupings are still available in your data, but you have to make some changes to it. Okay, so let me go ahead now. So then data, I'm using the base data. So that will be group by. So I can decide to group by the country. So basically that would be the right thing to do there. So the country. So looking at the country. So remember, you can also group by more than one variable. You can decide to group by country, date. Depends on what you're looking at. But for today, we're looking at just one. So we'll summarize. There's another function in dplyr, we're summarizing it. So we want to look at, let's look at the total number of deaths. Let's just summarize it. We want to bring them together. The reason why I'm doing this grouping, for you to really understand that they are repeated values, you can check within your console or here. So I can say unique value, that would be data dollar. So if you want to access any of the variables there, sorry, I should have talked about that as well. Any variable within your data, you can always access them using the $sign. So you just click this. So if we want to know the unique values that are there. So how many unique values there? So we have 54 unique values. So, but we have 39,636. That means they are repeated so many times, which I don't want to go into getting out of how many number of repeated. So that would be kind of too much here. So we can group based on, we want to get something unique out of it. So another thing that we need to understand is having the categories now, they need to be unique. Okay. Sorry, there's a question here. Yeah, there's a question from John. Can we import the results to other environments? Should we have to send it as a report to organization manager? We're going to get to that, which Stephen is going to handle after this session. So let me just go ahead and round this up. Okay. Okay, so for the uniqueness now, I want us to look at the grouping. So for grouping, we want to look at the total, let me just say total deaths. It's going to be equal to sum of death. Okay, yeah. So if we execute this line, we'll be able to get something shorter. So it's going to be unique now, so that you can see what is available in our console is 10, the first 10 observations, the results that we're going to get. So that is the countries, the first 10 countries, then the total deaths so far with the other 44 more rows. So we can view that in Excel format. So view. Okay. So I run this. Okay. So these are the 54 rows. So for all of them, we have all the total, the number of dates for all the dates now summarized. So that's what we're having here now. So I want to go and manipulate the data to help us do some visualization here. So let me, I'll do the cleaning again. So for the visualization now, let me say data underscore cleaned. So this is going to be equal to, we're taking the data again. I think you can understand now, so that I use more of the time well. So I will copy all this. Control-C. So other things that we can do here, let me use the function. Okay, we can go ahead and okay. Okay, sorry, for the time on our side here, I won't be able to go into looking at the structure of our data. We're looking like how we can make wide data come down to being longer instead of being wide. It's part of the tidy mentality. Sometimes you might have kind of not so much meaning when it is too wide. So you might want to collapse it and make it longer rather than having it kind of wide and stretched out. But I can display that. Let me go to, I think there should be the scripts. Okay. Okay. Sorry, let me finish up with this. Sorry, I'll come back to that. I'll go back to the wide and the long data now. So I'm just being reminded now. So what do we do now? So for this data now, I want to mutate my data. So for the factors now, what do I do? Okay. Okay, so I'm grouping. We'll group by this. Then we'll have the data cleaned up. This is 20. Okay, let's see what this gives us. So okay, 54. Okay. Okay, somebody is asking a question here. What is the use of as factor? As factor is a function that helps you to convert characters into categorical values. I hope that answers your question. Hello?
Yeah, but what is the like used in data analysis here in this particular example? Could we do everything? I think Stephen has clarified that we could also use group by without having to convert from character to this thing factor, categorical variable. So I was just a bit, I just need some clarification why we need as factor in this example.
Okay, the reason why we need as factor in this example is because we're going to visualize some data. When you want to visualize data, it is better it's better to visualize categorical data than character data.
Yeah, thanks. Yeah.
So, okay, thank you so much. So now the next thing that I want to do is that I want to, let's look at, I would explain, just ask the question, but I want to kind of, let's look at the scripts that we worked on. So to buy the time, I don't want to take much of our time here. So let me take out this. Okay, there are still some things here. Okay. So, okay. So Control S. Okay, I want to talk about, okay. Let's quickly talk about, because the time is running and I want Stephen to come back in here, but I still have the visualizations to do. So I want you to get an understanding of what we're doing now. So what I'm trying to do here is this. There's another function that helps you to split It's not the only one, but this I'm just using as an example. It helps you to split a column into multiple columns. You can separate it into multiple columns. So from what I have here, I can split the date column into multiple columns like the month, year, day. So that is what I'm doing here. The argument here is that, okay, which column am I splitting then into how many columns? So that's what I give it as the concatenator, the combine function. So, and what is separating them? How do I split? You need to tell me how I would be able to know where to split the character. So that is this. So then, do I want to remove the column or not? After I've split and created the new columns that you want, should I remove the old one? So that is it. So that's what I'm saying is false here. It's false. So I will run this quickly so that we see what the output. So that is it. So we have the old column, that's the date column is still there. So we have country, date, month, day, year, confirmed, death, and recovered. So these are new columns that I've added now. So now we have 8 columns instead of 5 columns that we had before. So that's then splitting now. So then the next thing would be, okay, looking at wide and long columns. So there are functionalities. And the scenario here would be, you have columns that maybe they said, okay, student in class 1 or grade 1, student underscore grade 1, student underscore grade 2, student underscore grade 3. These are there as a result of your data being wide. This can be collapsed and make longer. Another thing that you can do is that, okay, I'm okay with the data being wide. So either way, you can do this together. So in this instance, I want it wide. So that's why I'm using the function pivot wider. So from which area, where am I getting the names from? I'm making it wider based on the country name. So the values are going to be from confirmed, deaths, recovered. So this is going to give me the names of each column. So it's going to be so long, 54. It's going to be, because there are repeated countries there. So it's going to just widen the data and it's going to go the long way. But it's going to now take, if I'm going for Afghanistan first, it's going to combine with confirm and give me the value there, and so on and so forth. Afghanistan dot confirmed, Afghanistan dot death, Afghanistan dot recovered. So that's it. So names are going to be separated by this. So if I run this now, so we need to save some time and we want to look at it. So this is kind of weird that we now have 163 total columns. So this, you might need this, but sometimes the data might come in this format. So that's when you will not have to do a lot of manipulation to get it back into the format that makes sense to you. So with this, what we have here now, I tried to, okay, we need to use this same data, but I have to go through a long way to bring it back to the long one. So it's not as easy getting it wider as bringing it back to the long format. So this is what I did. I tried to bring it back into the format where it was before. So I did, this is the data, wide data. I want it to be long now. So I'm now going to use the functionality pivot longer. So what I'm going to do, the function is that, okay, I want to make everything long because I don't like the way it is. Then the date column should not be included. Don't include the date column because it's not part of the corporate that made it wider. So I want you to kind of give me a longer table this way. So what I did here, names is going to give me back the data in 2 columns with these 2 columns plus the date. Then look at the pattern. The pattern of the names that we're having now is that the data type that we collected is the confirmed case and the name of the country. So I want it to just split based on this dot, the dots in between them. So and give me back the data. Where am I? Okay, here. So what I did here is a reg expression, which is out of the scope of this class. You can research more on that. So just are the dirty work that we do, the necessary work that you need to do to clean dirty data. So this reg expression helps you to tell R that, okay, for you to be able to help me, the values are in this kind of format. So that's what this reg expression does. So, and I will run that, then you see the output. So the output now is this. So I have the date, the D type, country, then the values. But this is not what was there before. Now, the first thing is that, okay, all this group, the first values that we're having, they're going to be confirmed cases. So the few rows that you see, they're going to be confirmed, followed by death, then recovered. Now I'm not yet done. I'm not done with the work that I have to do. That's going to be a long one. So I have to do some manipulations again to get it back in the right shape. And that's why I have to do the second step. So here now I need to group by the D type. So that's the data, the type of data that we're collecting the values for. Then I added, mutate also allows you to add a new column. Okay, so just like what we did here, that, okay, we split the separate column, we might as well as do it through mutate, the mutate function. But here now I'm creating row numbers to help me get my data back. I need it, is necessary. So I need to create that column there, but I would take it out. Okay, I'm going to take it out now. So pivot wider now. So this is going to be this. Let me see. Did I get it right now? Okay. Okay. No, there's something missing here. I need. So okay. Let me see. Long. Okay. Now I am going to take out. I don't need the. Okay. So select. What's the name of the column now? Row. Okay. So I don't want the row. So, okay. So another thing we can do with select function is that you can negate a column that I don't want it returned. So if I do this now, sorry. Where is D type? No. Okay. So let me take this. Something is going wrong. Cool here. Sorry, that's the trauma of live coding. So okay, let me try this again. Okay, that works. So I will do it the beginner's way. Data underscore long. Okay. Okay, that will be data underscore long. Okay. Select. Okay. Okay, I think the row column, I don't need it. I just needed it to get my data back. So So now I have my data back the same way. So if you look at the data from the beginning, is the same thing now. So that was a lot of brain rack in there. Okay, so you can see the first value, then the same thing here. So that's something that you can keep in your portfolio, maybe your repository or something, and use it in future to solve some problems there. So that's that. So I'll have to take the scripts so that we'll use some time. Well, here. Okay, so I need to buy some time now. Okay. Okay, so I'm going to go ahead. There's another, the package that we're looking at now for data visualization is also part of the Tidyverse package. So I hope I've not lost anybody. Any question here? Yeah, thank you, Victor. Dplyr and Tidyr, yeah, they're kind of, would I want to teach Aurora that language? Yeah, okay. Okay.
One small question, Bilikisu, one small question. There, here in the last part of this code, value is, what is this value? Where is it coming from? This thing, values underscore from equal to value. We have no variable. Right?
Okay, yeah, okay. This function, okay. Okay, let me add this at this point. If you're lost with any functionality, as simple as select function, I need you to take it to the secret here. There is a tab on with this where here, okay? The tab on the file pane here. So if you're lost with any function, especially packages that are commonly used, there are some packages you might not get enough documentation on them, but for the Tidyverse package, there's a lot you can get here. You can even use the code here, the script here, and run it, and it will work perfectly well. So that's that. So select, let me tell you, you can type in anything here, and you get a complete documentation to get an understanding of what you're actually doing. So then for the pivots longer or wider, okay, you can get a documentation here to understand all these values that I'm using, all these arguments that I'm using here. We're looking at the time constraint. We don't want to tie you down so much, so that's why I'm kind of rushing. So I would explain now. What I'm doing here for this function is that derive the names of the columns from this column D type. You know, we created these two columns from here, D type. Let me do it again. Okay.
Yes, you see, we created two columns with confirm dot country and confirm dot.
Now let me take you there now. So we have the D type and the country. Okay. So this is kind of still long. I still need to get back the columns that were there before. The country, the confirmed, the deaths, the recovered. So all these four columns, I need to get them back here. These two columns, D type and country, I need to look for a way of getting back the remaining one that is kind of hidden here. So all the columns, the other columns, that's the confirmed, recovered, deaths, they are in this column D type, okay? So what I'm saying here is this. The next thing that I need to get back my data is that I need to, first of all, group by D type. For every value in the D type, group the remaining data based on that. Then I now created a column that's the row number, which is going to help me. The normal thing for you to do is always ungroup. After you have achieved that, you need to ungroup for the data. So then pivot wider. This is going to be names from derive the names. I'm telling this function pivot wider, make it wider, but the names of the columns, you're going to derive them from this column D type. Okay, do you get that?
Yes, this part, until this part, it is okay.
Okay, good. Then the values for each, for these columns that you created using this, the values in this D type, use the values for each of those columns are going to be derived from this place, this column there. That, you know, we have another one here, value. Do you get it now?
Right.
Exactly. So it's going to do it in such a way that for any confirmed, you take the value. For recovered, you take the value, the corresponding value. So then for the death, it takes the corresponding value. So that's what I did here. So that is that, and it worked fine after a lot of tests. So, so that is it. So now we have these results now. So this is the row column that actually helped me to achieve that. Then I need to take it out because I don't need it. So that is where the exclamation mark here comes in. So I'm telling R, using this dplyr function, negate this column, don't return it. So, and also save it back as data_long. So that's that. I hope you get that now.
Yeah, thank you very much. It is very much clear. So first we group and then we ungroup in the second and the fourth line in the 81st. So we group and then ungroup.
Yes, that's something I've learned from someone like a mentor, a real mentor. That's Mark Dancho. So in the courses that, okay, when you group, always cultivate that habit to ungroup your data afterwards. So I think I can ungroup here and I can take it back after completing what I'm doing. So it's better for you to ungroup so that you have the value as just a single value, not a grouped value.
Okay, thank you.
Yeah.
Yes.
Yeah. So that's it. So now let me try this and see. Okay, let me go so that I don't get into so much trouble. We'll save so much time here. The data cleaned here. Okay. Let me use this. Okay, so I'm going to replace this. Okay, so I don't want to go back to this one. I will replace it. So I'm going to run this. I'll explain. Don't worry, I will explain everything. I just want to save time. So now what I did, the cleaning here is that I converted the country into categorical values using this function. You can either use as_factor or use this factor function. Okay, so either way, I want to create a categorical value. So then I also want to, because while trying to create the script, I run into some issues. So I want it to create all the levels. When you're creating categorical values, it's going to create the values using some levels, some labels by itself. Categorical values like, okay, if I said you are a Nigerian, thousands of people can be Nigerians, but they will have the label Nigerian. So if you are an Indian man or woman, you're going to have that label India. Okay, so I might decide maybe in future you might have something like Nigeria black, Nigeria white or something. And I want to give it a label that is different from that Nigerian white, Nigerian white. They are all Nigerians, but I want to give it a different name. You can come to explore more of the functions of factor. So, but in this case, I know they are repeated values. So I just want to be specific to R that, okay, the levels, I want it to be based on the unique values within the column country. So then also the label, make it unique based on the names of the country, not just the repeated values or something. So that is what I did here for the first mutate. So I transformed that column to be this way. So then the dates, just like I did earlier, I also did the same thing here. I transformed the character into into this thing. So into dates, sorry. So I need to do this here as well. You can do this, you can leave it, but it's okay to always do that. So always ungroup it. So that is, so we summarize now. So we now have, okay, clean data. Okay, let me see. Okay, so clean data, where is it? Okay, this is it. So this is what I have now. It's just on demonstration purpose to teach the class. So now I want to go into looking at visualizing our data. Most of the time, looking at just columns and rows might not give any meaning to any executive or maybe your boss or something. You want to make meaning out of the data. You can see we're coming from 39,000 plus observations. We're narrowing it down to 54 observations with unique countries. So now what the information we're trying to give out now is that maybe in Nigeria, I look at all the states in Nigeria, but the data has been given to me based on dates. So, but right now, okay, let me just give specific information. Maybe my boss said, okay, I just want to know the number of deaths so far. I want to know the number of confirmed cases so far. I want to know the number of recovered cases so far. So that's where you need to do some analysis. You need to summarize your data. So that is what we did here to demonstrate how you can create the our visualization. So instead of giving him back this black and white column and rows data, you can go ahead and create visuals. They said visuals or pictures speaks much more better than just numbers or characters. That is what I've heard, and it makes sense. It's working up till now. I don't know about tomorrow, but the visuals helps a lot to make quick insights into the tons of numbers of alphabets that we're looking at. So this is what we're going to be looking at now. So the next thing that I did again was, don't worry, you'll get used to it, don't be scared. One thing you should know is this: if I'm going to do something similar to what I have here, the most important thing for me to do is to keep this script. This script, you can run it over and over with the same data. So don't be scared about the code or something. Okay, the code is too much and all this stuff. No, you are reproducing or using your script every time you need it. That's where automation, you can automate, you create packages. Like what the package that Stephen and Victor did. This package will help you to work without you having to write the script over and over again. You just need to be updating them. So going on now. So I still need to transform my data. I still need to do that. And this is the beauty about creating factors. Factors are the forecast package helps you to do a lot. For the countries that we're having, if you look at the data, the clean data, you can look at the total deaths now. They're not arranged in a way that makes sense. I can see 20,000, okay, okay, sorry. We have more than 200 here, I think I can see. So then followed by Benin, that's 52,000 plus. Then another one that is shooting up here, that's 551,000. So we need, okay, I want to arrange them in an order, like a decreasing or increasing order. So that's where having a factor or categorical value comes in. It helps you to have meaning or sanity with your data. So here now I'm using this factor FCT, anything you see with starting with FCT, those are functions that belongs to the forecast package. Forecast package, okay? So they help you to deal with categorical data. Okay, so now before I want to visualize, before I can visualize my data, I need to put it in the right order so that whatever picture that I'm bringing out will reflect the same thing as the data that I'm having. So now this FCT underscore reorder now is helping me to arrange the countries based on the total deaths in decreasing order. Okay. So I'm saying a decreasing order. So give me back in decreasing order. So all this transformation, you'll be able to appreciate it more when we visualize it. So then the next thing here is this. If I use only, sorry. Okay, I wanted to do something here. I didn't finish up this. Okay. So that will be for another day. Okay, so if I decide to, okay, let me create this. Let me run this. I'm not going to join it to the next pipe. So I will run this, Control Enter. So this, I would view it. Okay, so if you look at the data, the returned outputs now, it's not showing anything. Nothing is not showing that it's ordered, but the ordering is going to be demonstrated in your visualization. That is where the beauty of your categorical values, you appreciate it more. So another thing that I did was that I have 54 countries. Would I want to put, okay, let's go ahead and do that here. I'll go ahead and run this. It will work. So I'm going to explain this. I'm trying to create the plots now, so you view what I have. Okay, good. So I'm going to zoom this out. Okay, do you see what I have here on my screen? Can you see the plot that came out? Sorry, I need a response.
Yes, but it needs to be
Yes, it is.
bigger.
As you can see it.
Okay.
But it's small. Could you expand it so that
Okay,
it's bigger? We see what's there.
Okay, can you see it now?
I can see it, but it's kind of small.
Still small? Oh, okay, let me see. Sharing this. Okay. Okay, can you see it better now?
Yes, perfect.
Okay, good. So can you see the axis, the x-axis down there?
It's squashy.
Exactly. So it will make sense. We don't have to display all the countries. Maybe we can just show, okay, maybe the first 10 that are having terrible number of deaths, okay? Or rather unfortunate there, may their souls rest in peace. So we want to show the first 10, and that is where I'm going back to my codes now. So in order to do something better, I need to lump up the remaining 44 as orders. So I just want 10. I can set to maybe the first 20, but in this instance, I think 10 is okay. So that is where this function now comes in, FCT underscore lump. So this, I want to lump up the country, okay, to just the first 10. Okay, so every other country, I want to lump them up as a single value or observation called orders. So every other one is going to be orders. So it's going to add up all the values, and you'll see the transformation now. So if I do this, it's going to work. But one thing is that it will make sense. That's the reason why the last one now. Why am I lumping them up? I want to lump them up based on this weight. That's the total number of deaths. Lump them up based on that, because the first 10, it should be based on the total number of deaths. Which one tops the ladder on the scale, the highest number. I hope you understand that. So don't just give me 10, the first 10. It's not going to even return anything. So what I want you to do, it will make sense if you base the first 10 on the number of deaths, then you return them back to me. Okay, so that is what I did here. So I run that. So I have my data there, ggplot2. You won't see it there. So don't be scared. You will not see it here, but you appreciate it in the visualization. So now let's go ahead and use it in our visual, the plots. Okay, another thing is this. Let me explain the plot before I go ahead. We already see the outcome there. What I did here is that I saved this as an object. The visual that I created, I'm saving it as G. So this is the data that I'm using, and you understand the pipe. This is the pipe. So the next thing is the function. Sorry, can you hear me? My network is fluctuating.
Yes, yes, I can. Yes, we can.
Okay, good. So the next thing is that I'm using this function that comes from the ggplot2 package, which is within the tidyverse package. They're all tidy packages. So I'm using this. It takes in another function, which is for the aesthetics. There are some layers. If I run this first layer like this, Control Enter. If you look at my, okay, let me zoom. Okay. Can you see the plot?
Nothing is displayed.
Exactly. So that is the first thing. The first thing is that I'm taking in the data and I'm telling ggplot that, okay, create like a foundation for me or a canvas. The y-axis is going to be for the total number of deaths, and the x-axis is going to be the country name. And you can see down there, it has all the 10 countries with the orders value, okay?
I can't see the x-axis, only the y-axis.
Over. Okay, let me see if I can reduce that. Okay, can you see it now?
Yes, I can.
Okay, awesome. So that's good. Okay, so let me close this. So now that's the first layer. We've gotten our aesthetics. Now I know where my x-axis is, and I would know what's going into my y-axis now. So the next thing is this. This layer, no, let me take this out of here, Control X. Okay. Which one is missing there? Okay. Okay, so I want to take one by one. So what I'm doing here is the next thing that logically you should do is that I want to tell the ggplot function here. Now you've created the aesthetics now. Now I needed you to create a plot, a column plot. That's the geometry now. Now let me take this out and show you. There are other plots that you can create, visualizations. I mean, so if you say geom, immediately you type geo, it will give you all the options, the various plots that you can create that are in ggplot2. So you can create the area plot, bar plot, box plots, point, that's for the scatter plot, different ones. But today we are looking at using the column plot. So it's just the sister or brother to the bar plot. So that is what I'm doing now. So this is to create the object itself. So I will take this now and let's see the output. Okay, can you see something is now there? Okay.
Yes.
Okay, awesome. So, okay, maybe I don't need to make it zoom in and out again. So, okay, now I collapse this. So the next thing is this. If you look at the y-axis, kind of ugly somehow. I don't want it 3e plus 0.7. Nobody understands that, okay? So this is where we now come into kind of transforming our visuals, make it more beautiful. So that is what I did here. So the next one. Okay, can you see?
Beautiful.
Yeah, thank you. Okay, so that is that now. So, but this needs getting used to. We can't deal with everything now because we've used a long time here. So then we can make more sense with our visuals by giving it a title, then change the title on the Y and the X axis as well to make sense. There are other things you can add a subtitle and all this stuff, but this is just for this class. Okay, so now we have something that makes sense there on both axes, and I also have total number of deaths per country or region. So at least if I present this to my boss, he or she would be make more sense out of it. So that's that. So that is that. So I'm going to save this as an object. So I'll click that. So if you want to know, so you can see it here in the environment. So it's an object now. So you can see it's showing you have the data there, you have all the layers, the aesthetics, everything, if you explore this. So this has something for another day. It's a webinar on its own to understand all this, even a workshop. There's a workshop that the creators of the ggplot had to do 2 days. Some might go more than that. So for you to understand everything here. So I've saved it as an object here. Okay, let me close this. So now, okay, I'll run this. So it will give you back the visual. So now, if you look at my, yeah, my visual is beautiful, yeah, but not interactive. You can't get the value for each of the boxes there, the bars. Okay, so I want to quickly make it interactive, and we'll round up on that. So I think I've done enough justice today. So, so we have the same thing, but now if you put your cursor on each one, let me zoom now and new screen. Okay, if you roll over it now, you'll see the values for each. So it did for South Africa and the total death. I could have transformed that as well, but it's kind of, so that's for another day. Don't worry, just watch out for a new webinar on our channel, on our group, that will be able to deal with that soon. So now you can get the values as you roll over. So my boss should be happy with it. So I hope this makes sense. Does it make sense?
Yes, it does. Thank
Yes,
you.
it does.
Yeah, thank you very much. So I think at this point, I'm going to round up. Thank you everybody for staying with me till this time. So any question?
Well, I just wanted to say that initially you were not adding the plus when you were lumping up things together, but I noticed that when you ran the command, it included the plus to join everything together. I know you highlighted it before you ran it, but in some of your earlier functions that you wrote, you didn't put the plus to say that they are all together and should be run together.
Oh, okay. Sorry for that. Okay, for ggplot2, instead, okay, I would liken it to the pipe functionality. For you to add all the layers together, you need the plus sign. I hope that's what you're referring to.
Yes.
Okay, so yeah. So for all the layers now, you need to add them up using the plus sign. Sorry for that. So it's just to, I'm just kind of trying to manage my time. Thank you for that question. So all the layers would be added together using this. You can also add another thing. The theme, if I want to change the theme of, so I don't want to take us out of that. So that's another, so there's so many layers that you can add, okay? So, but for all the layers, instead of using the pipe, you use the plus sign. So I hope that answers the question.
Yes.
Okay, then this is another package that we didn't mention, that's Plotly. Plotly helps us to generate interactive visuals. So that's that. So, and it works with ggplot2. So thank you so much. So at this point, Q&A and So do we have questions? So questions now. Yeah, we can make plots. Okay, I have a question here in the chat. Can we make a plot of the normal curve with the data? It depends, but you have to do a different type. You can't use the data that I'm using now to create the curve. So that is it. So any other question? So whatever plot you want to, you have to create your data in such a way that it will bring the output the way you want it. I hope that answers your question, John.
Thank you, ma'am.
Okay, thank you so much. So do we have any other question? Okay, because the next aspect is going to be taken by Stephen, and I need to release my screen now. Stephen, are you there?
I am here. Thank you for the wonderful session.
Okay, so I'll thank you so much for hanging in there. So I'll stop sharing now.
Okay, so thank you so much to our participant for staying until now. I'm just going to go ahead and share my screen again, and we'll go to the last part of this webinar session today. Right, so we've gone through the first part, and we've had hands-on demonstration with Bilikisu. So we're just going to go ahead, and now that you have your plots, now that you have those beautiful charts and you have those wonderful tables that you want to be able to share with your colleagues, with your supervisors, with every other stakeholders that needs to see, how do you go ahead and do this, right? So we're going to be following this simple outlining. Can you save those charts, beautiful charts? How do you go about sharing those results, and where do you go if you want to learn more regarding R and how to use R for analysis and things like that? So basically, looking at outputs, most often your outputs are either going to be tables or they're going to be plots. We've looked at using ggplot2 package for charts, for plots, and we've looked at manipulating and getting results in tables and the rest of them. So you probably might want to save your outputs for your tabular data. You might want to save them as CSV file. You might want to save as Excel and other file formats, all right, that are supported. It's possible. How can I help you export those tabular data, those results that you have gotten, either as CSV, Excel, or the other file types that you might be interested in. And then you can take those files and then share them with others. I hope that maybe by the time we're rounding up this, Bilikisu might just be able to come back and show us maybe in 5 minutes how to save ggplot2 plots or charts, or how to probably export one of our tabular data as a CSV. And then we can look at more of those ones. But just to let you know that you can export your tabular data in various formats, and you can also save those wonderful plots that you have made, either as PDF or as PNG or pictures, or you can save them as HTML. All those options are available for you, right? So when you have done saving those files or those plots and those tables and the rest of them, you might want to go ahead and write those reports. R is also excellent for writing reports. You can write your report completely within the R environment. You can use R to create a particular package that we call R Markdown that we have also used to design the slides we are showing you today. You can use it to design or build your HTML files that you can put there on the web and people can read, and others can also get to see. You can even use those HTMLs, put them together and use it to design a blog site or a website that people can also go to. You can write your Word document, write it from R so that you embed all your results within your Microsoft Word document. You can do PowerPoint, not just slides right now because this is a slide presentation, right? But it is not PowerPoint, but you can build straight up your PowerPoint right from within R so that when you export it, it's going to be with the PowerPoint extension. And that becomes easy for you to share with all the necessary persons. You might also want to consider people sharing your result as a PDF. Again, just to let you know that these things are possible, we'll probably take a different workshop altogether to be able to demonstrate to us how to do these things. But there are so many possible ways in which you can use R to communicate your result. It's more or less like you just think about it, and it's almost likely going to be possible within R itself to be able to do. So it helps you put all of your workflow in a single platform where you're able to import your data, you're able to manage it, create the results that you want. You're also able to export your results and automate. So imagine you are a staff who does a weekly, let's assume a monthly analysis, and you also use the result of that analysis to write your report that you share with other members of your group. But maybe until now, what you used to do is you're going to get the results in another software and have to start copying the results into maybe a Word document, and then you need you convert that to PDF and then share it with others. Imagine all the copy and paste that you will be doing and all those other things. But now you can just automate the whole process. Write your script, get your result, and tell your Markdown file that, okay, I just want you to input all the new updated results every time I run the script. Put all the new ones, and in the click of the button, I get my updated results, updated report at the end of every month, and I share it with people. So that's the basic beauty of using R to manage all your processes, right? So a little bit about Markdown, just to let you know, and I'm going to use this particular Markdown that we have used to design these slides to walk us through this. So basically, our Markdown contains about a few parts. You have the embedded, what we call YAML header, yet another Markdown language or something like that. YAML header displays that is in between these 3 horizontal lines up here and 3 horizontal lines down here. It gives you, helps you to tell a little bit of details as to what kind of file what kind of output do you want to create, the author, the date, and a few other things like that. Then you can embed your code chunks so you can have all your analysis and the results. I'm going to show us a few. We can see this is a code chunk here. We have, okay, we really don't have many, but if we go back and open one of the, I've just opened the first presentation we had earlier today, and then we can see a little bit more of code chunks there. We can see a code chunk here, basically. So it helps you to be able to embed some of those results that you have gotten into R so that when you run this, it just generates together with the result of your output. All right. So you can also have free text. So we have a lot of free text where you just write your standard writing and the rest of them, and your standard narrative, and it gets included. And you can have Markdown syntax also embedded. This will probably take a little bit of learning and exploration on the part of the interested person to understand a little bit. You can see, for example, my dashed lines here are being converted into bullet points and things like that. And this line 93 here that is preceded by a £2 is converted to a second level header and the rest. So those are a few of the Markdown syntax. Just to let you know that basically those are the major components of your Markdown, and then you can decide what kind of results, what kind of output do you want to generate. Is it HTML? Is this a presentation slide like this one? Is it a PDF or is it a Word document? And then you're good to go. All right. And then you can share your files through so many platforms. You can put them on the internet. R easily communicates to a lot of hosting platforms where you can host your output, and then you can share the link to your results or your report with others, and they get to see. It's lovely being able to chain all the steps in your analysis all the way to communicating your results together and sharing this with necessary persons. So, but again, today is just letting you know that, yes, you can share your results. And when sharing, our Markdown really plays a significant role, including building websites, including writing books. There are a lot of books out there on the internet that were completely written in our Markdown, right? So we've learned a lot today. The teacher has walked us through a lot, has shown us a lot of things, and I can imagine that people already might be feeling overwhelmed. But the good thing is that you're going to get access to the slides, you're going to get access to the videos, and you can take your time to revise over and over again until you're very comfortable. So, but having done all the things we have done today, where do you go from there? Yeah, there are other ways, other platforms available for you to learn. Absolutely. There are a lot of them. We can't run through all of them today, but I'm just going to be mentioning a few of them. All right. Number one is that there are packages built within R itself that helps to user to learn. And I've listed two of those such packages here. There is a package called Swell, and there is a package called Learner. We have already seen today how to install packages. So I want to believe that every participant on this platform right now can install these packages easily on their computer. You just use the install.packages function. So for Swell, it's going to be install.packages Swell, and for Learner, it's going to be install.packages Learner. Then you have to load any of the package by using the library function. So after installing, you can just use library Swell or library Learner, and then you follow the instructions. And right within our environment, you begin to learn more about R itself, right? There are online platforms. We've talked about the communities that are available and where knowledge is shared on a routine basis. That is also available, and I encourage everyone on this workshop right now to consider joining such community groups. Our Abuja User Group is one of them. So Abuja User Group is available on Meetup, on LinkedIn, on Twitter, and has a lot of videos on YouTube. Most of, or practically all of our previously recorded sessions are available. You'll probably see those ones that are relevant to you and can help you grow in your learning. So these are basically a few ways to learn. But if you also want other learning platforms, I've listed a few of them here. Coursera, Udemy, edX, and a few of them, Udacity and the rest of them, they have resources for learning R, and you'll find a few of them. You'll find this really useful. So you can check on those platforms, and you're going to see other useful resources. Of course, online, there are also a lot of our books out there that if you want to explore and you want to take on the challenge, you can consider looking through those books, and then you might be able to move through. Within R itself, Bilikiso has shown us how to access help. And the other thing you need to know is that most packages, or a lot of the Tidyverse packages, they have what we call vignettes. So if I put help here and I say package equals ggplot2, for example, and then I can see here it opens this window for me, this pane, and I can see user guide, package vignettes, and other documentation. So usually when you click on that, you can read through a couple of topics that explains how the package works a whole lot more. So you can click any of those topics. Most packages, especially within the Tidyverse, a group of meta packages, contain documentations like this. They're also useful for learning, and you'll get to really understand exactly all the functionalities that the package provides. So basically, I think these is some of the things we would love to tell you today. We do appreciate your time, really, and if you have any questions for me regarding this part 3 that has just been presented, kindly just reach out. And thank you. All right, thank you so much, everyone. Yes, Fidelis, I'll hand over back to you now.
Oh, all right. Thank you very much for that wonderful presentation, Mr. Stephen. And Ma'am Bilikisu Aderito. In the absence of no other questions, I would like to appreciate everyone.
Okay,
for
sorry,
participating.
before you go,
Okay.
before you go ahead, sorry. Let me just attend to what Stephen said about saving the plot, just a quick one. So, but we'll be sharing. Okay, we'll be sharing it. Okay. Okay, let me share now. Okay. Okay. Sorry, can you see my screen now? So a simple way to just save the GG plots that you're having is immediately within your script, just type the GG save and you put the name of that you want to save it with, maybe PNG, JPEG, whatever, but double quotation. So you'll have it within your project folder. Then the same thing goes with the PDF. So you have it. So let me just show you what I have in my PDF now. Although it's kind of big, I'll change, stop sharing. So you can adjust the size as you want, maybe not too big, not as big as what I have here. So you can do that and make the changes. So that's it. So thank you so much.
Thank you very much. It was very nice.
Do we have any other questions? Sorry.
Hello, everyone.
Hello.
Yeah.
So, thank you very much for the presentation. It has been educative so far. So I believe probably I don't know if this question is somehow off topic, but I think is vital too. So since this is Abuja Arrow user group, and I believe there should be community probably meetups, physical meetups, probably occasional, I don't know. So do we have community in other states aside from Abuja? I just want to know. Thank you.
Okay, let me quickly respond to that. I would say yes. For example, I think we have Lagos R users, and I think we have in Ibadan as well, if I'm not making a mistake. I think, Ma'am.
Okay, we have in various locations, just like you mentioned. We also have in Oshun.
Okay.
We have in Niger State. So where exactly are you based?
Okay, thank you very much. I'm in Lagos State. I'm in Lagos
Oh,
State.
awesome. Those are the premier users. They started it.
Okay, thank you very much. Thank you so much. I'm so grateful. Thank you.
Okay, thank you very much. Ma'am, is there another thing?
Nothing. So okay. I think you can round up now. Let's just go.
Okay, we'd like to say a very big thank you to everyone for participating in today's webinar. It's been a very educative one, and thank you so much to our guest speakers, Madam Bilikisu Aderinto and Mr. Stephen. You are awesome. We really enjoyed the presentations. So to the participants as well. So we do hope that we see you in our subsequent webinars as well, as we take ourselves through this journey of learning. Thank you very much and God bless.